Ah. Yes, Yvonne, I can see you. Can you hear me? Yvonne, I can see you. Can you hear me?
Hello, sorry.
Yes, definitely. Right. Okay. Loud and clear. Is my voice clear?
Yeah.
All right.
Yeah.
Ooh, okay. Your voice sometimes cut off, so if it happens, I'll just tell you lah.
Okay.
Okay. So Yvonne, long time no see, yeah?
Yeah.
You must have changed and grown a lot, right? So I won't assume anything from the past, right? Meaning, let's assume that I don't understand what you want or what you need, and let's use this 1 hour trial so that I will understand what you need better. Is that okay?
Yeah, can.
Okay, right. So I believe that's the purpose of the trial. So you can find out whether you can tell me what you think you need to, and you can also see whether the style is suitable. You know, maybe the style also changed. Right? Maybe the way I teach and the subject is now a bit different lah from last time in primary. Right? You're preparing for a level, right? Okay. So let's settle.
Yeah.
Very good. Now, is there anything you want to share to me first? I don't mean the questions. I don't mean that. I mean anything you want to share with me lah regarding this tuition and everything.
Not really.
Really? That's it? Not really. All right.
I mean, I don't really have anything to say.
Mm-hmm. If you do, yes.
Yeah.
Okay. I was doing that because your voice sometimes cut off, so I was worried I was missing something.
Okay.
Now, but if you do, I mean, it's just both of us, right? So feel free to share. Okay. Now
Okay.
we'll do some technical stuff so we can treat this like normal tuition, right? Okay. So your iPad and your iPad is from school, correct? Meaning to say you cannot install new things.
My iPad. Wait,
Yes,
sorry, can you repeat?
so the voice have some problem. Okay. So I was assuming that your iPad is from school, meaning you cannot install anything. Is that correct?
Yeah, correct.
Okay, good. Now, do you have Jamboard?
Jamboard I have.
Good. Then tell me your account. I need to share a template Jamboard with you, and then we'll use that for today.
Okay.
Okay.
I'll send you via WhatsApp.
Okay. Okay, right. So I'm copying your email and then I'm sharing a Jamboard. Okay, so I did share. Tell me, do you see a new Jamboard? It's on today's date.
Okay, wait.
Sure. Take your time, eh?
Have you sent it already?
I have. Okay, so sometimes it doesn't show up directly. So I'm gonna do. Oh, wait. I'm gonna send it through the Zoom, right? So, because I assume that your WhatsApp is not in your iPad, right?
Yeah. Okay.
In the Zoom, you just try to click that, see whether that works.
Okay, wait. Oh, but then cause I'm not using my iPad for the Zoom, so if I click on it,
Oh, your Zoom is in something else.
I cannot.
Oh, wait.
Yeah.
Oh, wait. Okay, so a wrong assumption. What do we do? How do I send you the link so that you can copy the
Can you like you can share like from the Jamboard you just share it. You already shared to my email, right?
I did. I did. By right, you're supposed to be able to see it in the Jamboard. Wait, let me try one more time. Huh?
Okay.
Yeah, I think I did it. So try. If not, we're not gonna worry about this. We're just gonna go directly to Jamboard. Yeah, confirm.
Okay.
I confirm. So
Wait,
it's like today's date, and then there's Sunday, and then your name, something like that.
no, haven't. It's not here because usually it goes to my Gmail, but like there's no message.
Correct. Because I didn't send the email, so I'm gonna try one more time.
Oh, okay. Okay.
Right. How do I do that? First. Well, I suppose you can check the Gmail. So let's do that. Ding ding. Okay. Oh wait. Wait. Ah, okay. Maybe an email is now sent.
Ah, yeah, have it.
Good. So click that. Once you're in, you tell me. Yeah.
It says something went wrong. Like I cannot access it now.
All right. Now, we're not going to troubleshoot much today, okay? So the easier way now is for you to make a new Jamboard. Go ahead. Sorry. Have you used Jamboard before?
Yeah.
Cross. Okay. So you tell me if you're not familiar, yeah? So create a new Jamboard. Share with me my email. I will type you in the Zoom also. So you are sharing with me. That works. So, okay. Yeah. You tell me if you're done.
Okay, I sent already.
Okay, so let me try to see whether I can access them. I don't see anything. My email seems correct. Oh, there you go. Right, so your Jamboard is untitled, right? Yeah, correct. Okay, now I'm going to test title.
Yeah.
Easier. Yeah, I see what you're writing already, which is good. Very nice. So let me type something. I've seen your smile. You've seen my typing trial, right?
Yeah.
Okay.
Yeah.
So sometimes in iPad, this is more towards iPad stuff. So sometimes the Jamboard doesn't register what I draw. So sometimes I'll say, Yvonne, go out and go in, meaning you really go out of this Jamboard and then just go in and then it'll refresh more quickly. Or sometimes if you sense, hey, how come Kakak Pili is writing something or drawing something and yet you cannot see? If you sense that, then maybe you should say, wait, Kak, maybe I should go out and go in, or you confirm with me, are you writing something? That sometimes happen to iPad. Okay.
Okay, can.
Right. Yeah. Okay. So Jamboard is for. I'm sorry. Let me confirm. Did you like using your iPad and Apple Pencil?
Yeah, that's what I'm doing now.
Good. If you're used to it, then we'll just jump right to it. We'll just use it, and it means using Jamboard most of the time. unless there's extreme objection, right? Feel free to voice that out, right? But if
Okay.
not, we'll just use Jamboard. And then that means since you probably still depend on paper, am I correct?
Yeah.
Okay, so we have to use a mix between paper and digital, right? So if let's say you have a question you want to ask and it is on paper, then the best way is just to take picture. Do you know that you can take picture using your iPad and Jamboard?
I yeah, I think can and
Right.
just the photo
Correct.
inside.
Try that now. And the way you take picture, you must understand, it's not the whole page. Because first of all, the whole page is probably too big for the Jamboard, right? Too big for iPad. We're going to focus on just the question itself. That means you take a picture and you crop, for example. That's one way of doing it, right? So do you have a real question in mind?
No.
Okay, chemistry, right? So if there's no question, then we go back to our WhatsApp app. Do you want to discuss the past topic? Do you want to discuss the current topic? Or do you want to discuss future topic?
Honestly, I think I would like to revise metals because I have a practical exam.
Very good. When is that?
In like 2 weeks.
All right. So when you say metal, let me confirm a few things. That metal means the starting from the reactivity series, right?
Yeah.
It goes to does it react with water, with steam, acid, and all the metal carbonates, and then sometimes quantitative analysis will comes in. Okay, at this point, I'm saying a lot of topics already. Does that all make sense? Is that what you're thinking about?
Yeah.
Okay, there'll be redox. Automatically in metal there'll be redox, and it actually links to electrolysis. So when you say metal, does it include electrolysis or it does not include electrolysis?
It doesn't, but like it does.
Let's just call it
Like
ends there.
never mind.
Right?
It doesn't.
It doesn't. So for exam
Yeah.
purposes, we don't care. We don't care about electrolysis. Good luck, no problem. Good. Electrolysis is complicated anyway, right? Does it include blast furnace?
Yeah, it does.
Okay. Corrosion, resistance, that kind of thing.
Resistance to what?
Like how do you prevent corrosion? How
Yeah.
do you?
It does.
Okay. So around there, so it is a rather big thing, not just in depth in this
Yeah.
series, right? Okay. So let's start with a very quick revision. If it is too fast, you tell me. Then maybe we jump into some questions. Okay. Right. So in page 1. It is true that certain things you have to memorize. For metals, the first thing to memorize is reactivity series. Now, Yvonne, your teacher may teach you how to memorize based on the monkey, whatever thingy lah.
Yeah.
All right. I would like to speed up. I would like to speed up this with a faster process. If you're already fast, good for you. But I want it to be as fast as possible so that you can make use of it immediately in the questions. Right? So let me give you an example of how I write down reactivity series. Right? Okay, now I'm writing something. Do you see what I'm writing?
Yes.
Good. Now, ding dong sub, ding dong sub. What did I draw?
Letters and circle.
Good, but it's not just any letters, it's carbon and hydrogen.
Okay.
Right. So, and then I draw 3 dots, 3 dots, and then 3 dots. Now, if you can see all that, please imitate that on the side. Just draw the exact thing.
Wait, draw the okay.
This exact thing.
Yeah.
Okay. I'm gonna take something like that. Good. Now, this is the basic structure of reactivity series, at least the ones that you have to memorize. Right? Every metal is actually included in the reactivity series, but we don't memorize everything. We just memorize some. Now, the top one is super easy. 1, group 2, group 3. I know they don't say as group 1, group 2, but basically that's it. Look. Group 1, group 2, group 3. The one at the bottom is also very easy. All the noble metals. Cu, Ag, and Au. Right? At this point, do you still say silver as silver? or you are used to saying silver as AG?
I can say both.
Right. From now on, the preference is clearly on the chemical formula, meaning AG.
Okay.
So if we say lead, it's okay to say lead, but better say PB or and better know that PB is later PB2 plus, something like that. Those kind of thing is sometimes taken for granted already, like for exam. Right? So the bottom one and the top one is
Okay.
easy to memorize. Just left the 3-1 in the middle. If you already can memorize them without the mnemonics, without the help, right? We just whack that. So I'll start with the middle one. The most useful metal currently in our lives is iron. And then on top is zinc, and on the bottom is lead. There you go. All right.
Okay.
Now I'm gonna erase mine. You don't have to erase yours, right? And you time me a little bit. See how fast I write. I promise to write in a very normal way. I don't write in a very rushed way. I want to demonstrate that this is very easy to write, and it must be done that way in exam because you have to use it immediately. Right? So you have a stopwatch, yes?
Yes.
All right. When you say ready and go, then I will start writing. I'm waiting for you.
Okay, ready, go.
Good. Observe my order. My order, I think, is important. Just to help us. Then, okay, I'm doing it in like a normal speed, expected for an exam. And then I'm done. Please stop.
Okay.
Okay, that's around how many seconds?
About 20
Good.
seconds.
Now, I'm gonna erase everything. And then when you're ready, I'm gonna erase everything. You don't have to time yourself, but just do it similar to how I do it. Are you ready?
Wait, I erase stuff.
I'll give you an example. I can click the clear frame. There's a clear frame button, right?
Uh-huh.
For example, boom. Okay, everything is gone.
Okay.
Hey, I accidentally erased. I just undo. You can undo things. Okay.
Oh.
But I really want you to, when you are ready, you clear everything and then you start doing it again. Okay, can you do that?
Okay, can.
All right. Now, you go yourself. How you go is just clear frame and then you just do that, right?
Okay.
Go ahead.
Like that?
Let me see. Yeah, perfectly fine. Right. So you should feel that this is not taking very long, right?
No.
Right. So, how does your teacher do it, or rather, how does your class usually do it?
My teacher just like she does the monkey thing, so like she writes the whole thing out.
Right. Or at least in chemical formula, at least right? Because if you don't write in chemical formula, some does it even worse. Some really like just the silver as really SiL, which is not good in this in fourth year, not good. I can see that the way you write is also very fast. So at this point, I'm not very concerned, except that you forget carbon, except.
I don't know, cause like they don't like in my school notes they don't put carbon inside.
But they put hydrogen.
Yeah. Like they put carbon as like the reducing agent, but like there's a section for like how they're like reduce and stuff. Then they just put carbon there.
Right. Currently, I'm not worried about your memorization. Obviously, you can do either way. Obviously, I'm just concerned that certain schools will do it in a very long-winded way, which is not a good way of doing it.
Okay.
Okay, wait. Okay, my drawing pad. Okay. Okay. So now I'm going to add a little bit of information, and then that is already our first revision. So. So unfortunately, we still have to discuss a little bit of things to memorize. Drawing pad. Okay. There you go. Okay, got it. Okay, so think. Now they don't do this in O level, but they are going to do this in A level, meaning this is the more complete knowledge, the more appropriate one. I'm still not sure at this point why they don't do this in O level. It is actually something that adds to our understanding, not make it worse. So what I'm doing it, right? Right? Do you notice something?
Yeah.
Right. I'm writing the
Is
ions, right? I'm writing the ion, right? Which is indirect mirror image to the one above, and that's not a coincidence. All right. Something happens in nature which is like that one. So the mirror image exactly. At the same time, I'm memorizing my my ions classes lah. So in case you're a bit weak on there, we fix that immediately lah. For example, after H plus is supposed to be PB. So PB is supposed to be how many plus?
2 plus.
Correct. Okay, good for you. And then FE?
It can be 2 plus or 3 plus, right?
Correct. Correct. And for simplicity's sake, I'm just going to put them side by side, right? And then zinc?
2 plus.
Right. And then C, it's going to be 4 plus actually, right? Okay. So then after that is very easy lah. At group 3, group 2, group 1, just 3 plus, 2 plus, 1 plus. So that's it lah, right? Right? Nothing much to it, right? So,
why is C
okay, your audio just cut off.
carbon 4 plus?
There you go. Your audio just cut off.
Like,
Try
why is
again.
it plus?
All right. So this represents the oxidation number. Remember, it is not ion here. Actually, this represents the oxidation state. Of course, ion's oxidation state is exactly the same as the charge, of course. But I'm representing the fact that the bottom guy is oxidized and the top guy is not. Right. So a state of the normal carbon, for example, this is coal or graphite, right? Just imagine that. Carbon can and will be oxidized given the chance, right? So let me draw the jump down, right? Jump down. And then C4 plus is again not ion. That's wrong to think. You must think a bit more like CO2. Look at CO2. The oxidation state of O is
Plus 4.
No, the O is minus 2. Minus 2. Then the C is plus 4. C. That's what I mean.
Okay, can.
So the carbon in CO2 is oxidized compared to the carbon in coal, right? Why is this very important? Because in jumping directly to blast furnace, right? So in blast furnace, you start with iron ore, correct? Very important question. Iron ore is this guy or this guy?
Is it just Fe?
All right, you think carefully. You think carefully. If iron ore, which is what we get from Earth, you have never seen iron ore before, by the way, correct? I've seen it twice, right? So not very helpful. But I can at least tell because I've seen it that it is it iron metal or it is not iron metal? Now, you have to do by assumption. You assume that it's iron metal. So think carefully about your assumption. You're assuming that from the ground, iron ore comes from the ground, correct? Maybe slightly below, maybe on top, whatever, right? We're going to pick up iron metal from ground. That is your assumption. Does that make sense? Or
not? Yeah.
All right. Think about it again.
Sorry, it's the other one because I remember it's the iron oxide thing.
Correct. I'm going to bolster that with understanding, okay? The iron that we pick up from the ground cannot be the iron metal that we know. For example, what is the reason for it? For example, in the chair that you're sitting, is it made of plastic or steel or something like that, or wood?
Yeah, plastic.
Plastic, or fully plastic, no metal. Oh, goodness me, right? Is there anything else in your room which is made of, iron metal?
I don't know.
Your bed legging? No, your bed.
Possibly.
Table legs? No.
Yeah, I think so.
Okay, table leg metal. Just knock first. Just check. Correct or not?
Yeah.
Okay, good. Now, let's pretend that you hate this table so much and then you throw it out. Okay, throw it out in the dumpster below. And then nobody pick it up and it rains for 30 days and 30 nights. What happened to the iron?
It will rust.
Does it make sense, therefore? This is just 30 day, 30 night, yeah? With rain, okay? Just to help things a bit, right? With paint, some more. Paint actually reduces the rate of rusting. You learned that, right? Protection, right? Does it make sense for iron metal to stay iron in nature, where you can pick it up as iron metal anytime?
No.
Correct. What you're taking from nature is almost certainly iron, which has already been oxidized, when I'm talking about oxidized, which means the iron oxide is a very happy thing. However, you wishes for it to go up to being an iron metal again. Correct, yeah? That's a human wish. Therefore, a blast furnace job, if you see it this way, is to sacrifice carbon for the sake of bringing the iron oxide back to the iron metal state. Right? Now, we can only do that because the jump down, so to speak, is bigger than the jump up. Your teacher probably won't say it this way. This is, however, the correct understanding in A level. It's not a complicated understanding. It's a very easy thing to understand. Correct or not? Jump up lower than jump down. Can that happen? No?
Wait. What do you mean by the jumping?
Good. Now, do you agree first that iron, this thing, okay? Very annoying name, right? Iron. So very, very difficult to say. The Fe2 plus and Fe3 plus. That's why saying Fe2 plus and Fe3 plus is better, right? Now, Fe2 plus and Fe3 plus, who's happier, this guy or compared to the Fe metal?
What do you mean by happier?
Correct. That's a human term, right? Something that you cannot use in exam. Cannot. I don't mean that. I mean understanding. I really mean you got to see the perspective of the Fe. Fe likes to be Fe or Fe3 plus, given the chance. Think from their perspective. This is one of the first things that you learn in secondary 3. So I'm not talking about something new. Let me put it another way, easier. Sodium metal, right? Na, right? Sodium metal. Sodium metal prefers to be sodium or sodium plus.
Sodium plus.
And how do you know that? It's correct. How do you know what they like?
Because sodium is like more reactive, so it wants to give away the electron.
Just one. And sodium plus. I mean, to be fair, sodium don't want to be sodium plus. He just want to give away the one extra electron. So, formally we say, oh, because that, the valence electron becomes full. No longer one extra one flying around. Correct? That's what we learned in Sec 3. Now, that's the fancy word of describing what sodium wants. Sodium does not want to become sodium. Sodium wants to become sodium plus. That's why all sodium that we meet is in the form of NaCl, which is not sodium, right? It's sodium plus. In lab, sodium metal is kind of dangerous because if it touches water, you know what happens? Wait, have you seen the sodium metal
explosion, I guess.
Oh, you've never seen it. Oh, goodness. COVID. Last year, still COVID, isn't it?
Oh, yeah.
Oh, goodness me. Okay. Never mind. Then knowledge-wise, you can accept that sodium is not happy, so to speak, and sodium plus is happy lah. That's what I mean. No?
Okay.
By extension, Fe is not happy, Fe3 plus is happy by extension. Okay.
Yeah.
Now, think about carbon point of view. No? Now, carbon, coal is up there, not down there. Down there is CO2, right? Coal is happy or unhappy?
Happy.
No, it's unhappy. Anything above is unhappy one, I guarantee you. That's why they are called reactive. Okay, so your teacher teach you a reactivity series. The guy on top, they purposely ask you to write in order from top to bottom because they want to communicate. The top guy is reactive. The lower you go, less reactive, or you call it more stable, correct? More stable. This is a very important clue. If you are reactive, it means that you're not happy with your current state. What? It means you want to react. That's what reactive means, right? You're very reactive. You want to react. When you react, you have to change to something else, not you anymore. That's what being reactive means. As we go down in this new place, which is just ions, this is more and more and more stable.
Okay.
This thing communicates to us that Fe is, more reactive and therefore less happy. Wanting to change to Fe3 plus, which is stable and therefore happy and therefore don't want to change. That's what stable means. What stable means? I am happy with my current state. That's stability. Simple, right? Reactive and stable. So far, so good. So therefore, coal on top is reactive. How do we know? Well, it means on top there. So that's one way, for the scientists to communicate their knowledge to us. Okay, that's one way. Another way is you go to barbecue, correct?
Okay, yeah.
Okay, you go to barbecue and then they burn coal, not you lah. Later you sting in coal. Okay, they usually don't let the girls do the burning of the coal. But if the coal doesn't start, no barbecue. So the coal burns. That's an indication that the coal very readily wants to react, wants to change. Coal burns become what?
CO2.
You don't sound confident at all. Ah, man. Now your mom say that you go and attend Olympic for chemistry.
Yeah.
Okay, come on. Okay. I'm not adding to your knowledge. I'm not adding to your better knowledge. I'm just explaining what the atoms and molecules think, right? Okay. Then hopefully you get a better understanding, right? Okay. Because things like this are more important in difficult questions. I am under the assumption that you have problem with difficult questions, not with easy ones, right? If my assumption is wrong, you gotta tell me immediately. I have to change my way of teaching. Right?
Okay.
Right. So is it correct?
Yes.
All right. Then if I explain to you some understanding, it'll be useful when things are hard. When this question doesn't make a lot of sense, or this question I don't know how to answer, those kind of things. So I try to focus on that. Okay. Yeah? So let's see whether that works or not. In the meantime, just follow me for a little bit more. Right. So when the coal burns, it becomes CO2. And you are correct, C plus O2 is CO2, right? You see that in real life, it gives off heat, exothermic, right? You're learning exothermic right now. And in reality, you see all the smoke come out, and you shouldn't go too close because it'll choke you a little bit, right? The unburned carbon choke you, but also the CO2 is crowding all the oxygen. So it's really not good for us to get too close.
Okay.
Right? So CO2. Have you ever seen CO2 burn? Is CO2 dangerous in any way?
Like just carbon dioxide?
Yeah, just carbon dioxide. Can it explode according to your chemistry knowledge?
I mean, if you supply energy, I guess it can.
No.
No.
It really doesn't. It really doesn't. It has exhausted any capability of burning. It is the result of burning. You think about it for a while. CO2 is the result of burning. Therefore, it doesn't burn. Because if it can burn, it will continue to burn. Because it is coming from a burning reaction anyway. There's
Okay.
already fire there. In the coal, there's fire, right? Coal is burning hot. It produces CO2. If CO2 can catch fire, you will catch fire immediately. It's produced next to the fire, something like that. If that makes sense.
Mm-hmm.
But CO2 don't burn. Oxygen burns. Yes, CO2 does not.
Okay, got it.
Right? So CO2 is stable down there very much. A blast furnace, in very simplified summary, sacrifices coal, so to speak, for the sake of bringing iron back to metal form. Right? We are happy to trade coal for the sake of getting iron. Basically, that's what blast furnace do. All other things are just to explain that process. Okay. Now, in metal, they'll ask you something like this, a little bit more advanced. So the aluminium is the guy here, correct? You have indicated it, right? So you know that carbon is here. This is not very important. So they will ask you things like this. So like they pretend to be a bit unknowledgeable. Can we obtain aluminium metal from blast furnace? They'll pretend to ask things like that. Okay. So can you obtain aluminium metal from blast furnace?
I don't know.
Wait, why you already wrong so early?
Huh?
I
what?
don't know.
Wait. I'll switch to more common metal, sodium.
Yeah.
Can you obtain sodium metal from blast furnace? When they say blast furnace, they actually meant from using coal.
Huh? What do you mean? Like,
Huh?
I don't like in school they don't exactly teach us like what the blast furnace does. It only like teaches us the process of extraction of iron. So like the concept of using blast furnace to extract other metals is new.
Oh my goodness. You're gonna have some trouble in exam, isn't it? I'm talking about O-level exam. Maybe not the current exam that you're gonna take. No, let's talk about exam for a while. Let's talk about O-level exam. Let's talk about prelim exam. Let's talk about the June exam. Is it? Are you going to have some sort of before prelim exam in either May or July, like either one? Are you going to have that?
Sorry, I'm actually not taking O levels.
Oh my goodness! I'm talking to the. So wait a minute. Why do you want tuition even session? You tell me again. Sorry, tell me again why you want tuition.
It's just because I'm a bit not confident in chem.
Okay.
Okay.
Wait, let me think for a while. Let's say I don't speak in terms of exam. Very happy, very happy. Very happy to not have exam pressure beside us. Very happy. You will still have some sort of end of year exam, something like that, right?
Oh yeah, yes.
But certainly you will pass that, right? No. Yes.
I cannot assume.
All right. Let's not assume it. Sorry, I won't be assuming. Sorry. You're right. Now, what do you want me to do for you? Okay. Because there are many options, right? You want me to prepare for the annual exam? We can do that. You want me to improve your understanding? We can do that. You want me to help you revise difficult questions? That means don't care about exam, don't care about understanding, but help me answer certain questions. Those are the common options. What is it that you want me to do roughly? It can be anything, but you want me to give you confidence. Is that the answer actually?
Not necessarily. I just want to like learn more about chem, and also because I prefer having tuition teachers to like answer my questions. And yeah.
All right. So let's say currently you don't have any question, not yet. maybe not yet, right? Maybe you will have to, right? Very happy to explain them to you, right? Very happy. But if I'm explaining too much for you, like for example, right now, am I explaining too much for you?
No, it's just like a different way of explaining than I'm used to, I guess.
Well, it is meant to be easier to understand, not more difficult to understand. Now, if it is more difficult to understand, I'll try not to do that, right? I don't want you to be more difficult, like life is difficult enough, right? Don't want to make your life more difficult, right? Is it, I don't know, say, is it not comfortable, so to speak?
It's new and but I guess I need more time to understand like where you're coming from.
Do you mind you needing more time to understand?
No, it's okay.
All right. Then let's go to the blast furnace. I have to check a bit with you. They at least show you the 5 reactions, right? No. Yes, no. Blast furnace.
I mean, yeah, we have they show us the diagram and like all the reactions that happen. Only specific to iron.
Right. Let me show you that, okay, because you know already. And then let me immediately say that how does it apply to other metals? Because tendency-wise in O-level, unless you don't take alpha, tendency-wise in O-level, they will take a concept that you're familiar with, and apply it immediately to a slightly different situation. I mean, a slightly different metal, for example, vanadium. Don't know where that comes from, right? I don't see any vanadium here, but vanadium is in the periodic table and it is extracted by a process similar to blast furnace. But we don't know that from the syllabus. Okay. Suddenly in exam, it will appear to you in its full glory in O-level. If I were to assume that your end of year exam is kind of gonna take hint from O-level, then those kind of things will keep happening. It doesn't feel nice when it happens in exam, we are taken by surprise.
Yeah, I think the questions is like they follow O-level.
So you're saying that it will be similar in thinking in O-level, something like that.
I'm assuming I haven't really seen the O-level paper, but I think it should be quite similar.
Right. Which tells us something very important. Around 15%. Okay, sorry. Maybe we do a better estimate. 15 to 20%. Okay. Around 15 to 20% of the marks will be the scenario that I told you just now. Old concept, seemingly new application.
Yeah,
that's I'm sorry, that's what?
Yeah, like in my exams, they also like to do that.
So you already know what I'm trying to say. For example, you ask the question, hey, but they don't teach you that blast furnace can apply for other metal. Yeah, they don't. And they will ask you to understand that in exam. Ta-da!
Okay.
They will do that, right? So they are trying to test your understanding. They are not trying to test your memorization. And that's what we're trying to aim for. For example, in this few half an hour, I'm trying to explain so that your understanding can encompass that kind of thing. I'm trying to stress your understanding. Right? In a way that still makes sense. In a way that is beyond syllabus, but not beyond syllabus. I don't know how to explain that. That's what happened in exam, like that one.
Yeah, I get it.
The purpose is like that. So follow me for a little while until you cannot take it anymore. You just say it. Okay. Okay. So in blast furnace, I say something very simple. Can you accept that? If you cannot accept, you must say immediately. I sacrifice carbon to obtain iron. Does it make sense to you or not?
Sacrifice as in like you make the carbon react with whatever is inside the iron thingy.
You see the reaction? You see the reaction. So this is a more complicated one, right? So the more complicated is C plus O2 becomes CO2. First thing, correct?
Yeah.
Then CO2 plus C becomes 2CO, right?
Yep.
Now, this is what they use to react. So they react with what? They react with the hematite, like hematite, CO, and then balance, whatever. It becomes, ta-da, the gold, right? There's the gold. Gold plus CO2.
Yeah.
Now, we'll call C the starting point, right? Here's the start. Right? Here's the start. To be fair, oxygen also a start, but oxygen is available everywhere, so they don't even consider it. In actuality, you need oxygen. Look at the start and the goal. The Fe is obtained, the carbon is sacrificed. You no longer have coal at the end.
Mm-hmm.
You are sacrificing your coal for the sake of obtaining iron. Of course, from iron ore.
Yeah, okay.
But you don't call that process sacrificing iron ore, right? Even though obviously iron ore no longer exists after the process, only iron exists, right?
Mhm.
Because you don't feel like iron ore is being sacrificed. You feel like iron ore is being transformed to something that you want, which is iron ore. Ta-da! But to be fair, coal has some uses other than blast furnace. Correct. What other uses does coal have?
Your barbecue.
Okay, yes, to barbecue chicken wings. One is, there are also other uses like that you may have come across. What are they?
Is it like fossil fuel or something?
It's power generation. Very dirty power generation, but it's still cheap power generation, which is something more relevant in China. You talk about Singapore, that's not true. You talk about Indonesia, just where your mom and coal power plant still exists.
Yeah.
And coal power plant is definitely more useful than barbecue, which is to say, oh my goodness, I'm sacrificing coal, meaning coal not for power, but coal to get iron. I am sacrificing coal. Coal is gone by the end of it. Sacrifice coal to gain iron. That's blast furnace.
Okay.
That I hope makes sense. I'm not trying to invent a story here. That is just a summary of what's happening.
Yeah.
Okay. So now here's a similar blast furnace question. I'm going to ask it in a very direct way. Can I sacrifice carbon to obtain zinc metal?
What? What did you say?
I'm responding to, I think, your brother. I think.
Sorry.
No problem. I'm enjoying the background. So back to our thing, Yvonne. Can I sacrifice coal to obtain zinc metal?
Wait, sorry. Can you sacrifice coal to obtain
zinc metal? Okay, zinc in the reactive.
I guess can.
You are right. Explain why according to your own understanding. Don't use fancy words. Use your own understanding.
Because after you just take the first two reactions, then after that you get your carbon monoxide.
Let's say.
And reduce your zinc.
No. Don't say zinc.
Yeah, your zinc, your Zn.
No. If you already have Zn at first, Zn2 plus. Good. Your Zn2 plus, you must say that. Then to become Zn, correct?
Yeah.
All right. Now here's the. By the way, the more practical one, you say ZnO, zinc oxide. Make sense? Because zinc oxide is zinc 2 plus, but you never find zinc 2 plus in nature. You always find it as, for example, zinc oxide.
Okay. Yeah.
So here's my question. Why do we even bother with reactivity series? Why? Because I'm going to now change the zinc oxide. Zinc oxide can, right? Can, no problem. Now I give you another problem. How about aluminium oxide? Can or not? Can or not? Theoretically, just take carbon monoxide, react with aluminium oxide. Get aluminium, can or not?
Yeah, can. I don't know.
You have a problem. Cannot. That is the contribution of reactivity series. That is the main contribution to tell you what can and what cannot. Let me repeat this. Reactivity series is a result of full experiment. We never do the experiment one, but the experiment tells the scientist who is more reactive, who is less reactive. So they just order things and then they tell this summarize. So far, so good, yeah? That's not what the scientist is interested in. The scientist is interested to say, oh, goodness me, we cannot sacrifice carbon to get aluminium. Cannot, because the jump up is higher than the jump down. Cannot. The most we can get is zinc. With zinc, the jump up is still smaller than the jump down of carbon. The scientists don't say like that, but I'm trying to illustrate a point here. And it is true that they ask this kind of question in exam, not even the most harder. They just say aluminum can or not. You have to explain why can or cannot. Now, do you actually know why can? Aluminum cannot, according to reactivity series. Why cannot?
Wait, is it because it's more reactive than
That's the
carbon?
formal, yeah, that's the formal explanation by the teacher. And you are supposed to explain that way. According to reactivity series, aluminium is more reactive than carbon. Ta-da, therefore you can. My question is, do you understand that?
Yeah,
Then why did you say just now can?
thanks. Sorry, why?
Yeah, just now you say aluminum oxide can react with carbon to get aluminium. Just now you say can. The first
Yeah.
answer.
Yeah.
But actually cannot. Are you sure you know why cannot?
Yeah, because the carbon in the carbon monoxide cannot displace out the and
Aluminium.
sacrifice for aluminium, I guess.
Something like that. Because explain it using the style I'm used to it. You see the jump up, right?
Yeah.
Jump up requires energy.
Mm-hmm.
Obviously, right? Jumping up requires energy. Jumping down releases energy, if that makes sense, right? And kind of something. The energy released by, so to speak, sacrificing carbon is still less than the energy needed to make the aluminium jump up. You explain that out by the phrase aluminium is more reactive than carbon, because that's actually what it means. The jump up, the energy required is bigger than the jump down, the energy given. Therefore cannot. Therefore can.
Mm-hmm.
So, can you obtain sodium metal from a blast furnace process, meaning the sacrificing of carbon?
No.
All right. Therefore, the question continues. Recommend what must be done to obtain sodium metal. What must be done?
Electrolysis.
Right. And you have a question mark. You're always correct in your answer. Now, why is the question mark there?
Because it feels like you're asking all the trick questions.
Probably cannot say it's a trick question because it almost always happens. It no longer is a trick question. It is a totally expected question. It is not a trick question at all. It is the reason why we study electrolysis. Why do we study electrolysis? Because blast furnace not enough lah. Something like that. Because carbon not enough lah. There is no other way but electrolysis lah. There is no other way. That's the spirit of the understanding. If you want sodium metal, you must do electrolysis. Then when you do study electrolysis, you must understand that, oh my goodness, cannot even use water. If you use water, we don't even get the sodium metal. Something like that.
Mm-hmm.
Right. So from this trial, yeah. I'm a bit confused what I'm supposed to teach. What I'm talking to you today, is it something that you already know or something that contributes to your understanding or a bit far off? Or how do you feel about it?
Yeah, it did help because I now know like the concept behind the blast furnace.
I guess. And electrolysis, I guess. Maybe.
Not so much electrolysis, but yeah.
Because you're quite good at electrolysis, isn't it? It does seem to me like. I mean, it's a good news, you see, because electrolysis is one of the hardest chapters. It is one of the hardest chapters. If you can understand electrolysis, not that, really not that.
But electrolysis is just the you connect the thing to the electrodes, then like it's just the movement of never mind.
No, not correct, not correct. That is how electrolysis happen, and that's one of the hardest thing to explain. If you get it, it's really good for you, right? I am zooming out and asking.
Okay.
If you want to call it trick question, as long as you can do the trick, I'm okay. For example, this. I'm going to give you the last question. And some people find it very confusing, right? Some people find it, right? So copper is here. As you have, copper is here. Copper is down there, and use blast furnace, like, correct or not? I mean, can sacrifice carbon. Actually, I can even sacrifice hydrogen. It's just that there isn't a lot of hydrogen. So we sacrifice carbon. Can. Make sense? So why do we do electrolysis on copper? Is it just for fun?
I mean, like my guess would be because electrolysis, it can like, you can extract any metal. Then like blast furnace is a bit troublesome, whereas like electrolysis, you can just connect, then that.
You are of course
like,
correct.
That's more useless, I guess. It's like you can verify the copper.
Finally, right? Okay. So you're saying a very convenient, like it's a very convenient process, right? Proven because electrolysis we can do on lab. I mean, we can do it ourselves, we can actually do that, right? Blast furnace cannot, right? But in chemistry, they bring in economy, they bring in like cost, so. But if you want to electrolysis every metal, it becomes extremely expensive. So there's a reason not to do electrolysis. You have to at least know that. So it's convenient but expensive. That means if you use electrolysis to produce every metal, for example, simply producing iron. If you use electrolysis to produce iron, can, no problem. The iron will be, 3 times more expensive, which is not something that we like. Sacrificing carbon is cheaper, and therefore we sacrifice carbon. I guess that's the reason why we use blast furnace. Right? But for copper, you mentioned the correct answer. The correct answer was that electrolysis is powerful because can purify.
Okay.
The carbon and the copper that you get is very pure. Now, then they go on, why bother with very high purity copper? That's a physics question they ask in chemistry. I'm so sorry. Do you know the answer?
Wait, like you mean what's the question?
Why do they want to electrolysis copper even though it's expensive? Oh, because it's very pure. You get very pure copper. Correct answer. Why they want a very pure copper? It's expensive, Why?
Because I don't know, you can. Yeah, actually I don't know.
Because physics. Because very pure copper is a very good wire. And you need that. And therefore, at that point, the question will stop most of the time. That's the furthest they will go. That's the furthest.
Okay.
Something like that. Right. Okay, all right. So at this point, I have some idea of what you understand. You understand quite a lot of things in chemistry. That much is true. That much is true. Right. I hope you have a feel of how we do things, how we do tuition. And then if you're going to continue, hopefully when you ask questions, you also get the answers that you want. Right? Yeah. I feel that I probably shouldn't start explaining concepts. I probably feel that I should answer your question first, then maybe add some explanation. I feel that's better.
Yeah, okay.
So when you have no longer any question, like for example today, then I will tend to usually go in advance. That means I want to discuss the next topic with you. For example, okay.
Yeah.
When that is done, then maybe I discuss the overall concept. That maybe there's a better way of doing it, I feel.
Mm-hmm.
Yeah. What do you think? That's what I
Okay.
think lah. So what do you think?
I think that would be okay because I also like want to learn the next chapter.
I feel that that's probably something useful lah. Yeah.
Yeah.
All right. Okay. So I hope you have a good sense from the trial of what's going on here, right? And then please tell your mommy whether you want to continue. If you continue, then we'll just confirm the timing lah. Mom said that you may want some sort of Wednesday lah. Is that correct?
Yeah.
All right. Then if you really want to continue, mom say okay also. Then we'll discuss the timing using WhatsApp and maybe we can just start this week.
Okay, can.
Okay. Thank you very much, Yvonne, for your time. I'll see you. I'll see you when I see you. All right. Bye bye.
Thank you.
All right, folks, the next is
Can you hear me?
Yes.
Okay, yeah. I was checking whether I owe you something. I wait,
I don't think so.
was the long chemistry question that good? Was the what should we do? Yeah. Or sorry, before asking you what you want us to do, I probably want to ask you, how are you feeling these days? How are you? Are you okay?
I'm okay lah. Like a bit stressed, but okay lah, not overwhelmed.
What's the stress about?
I think it's a bit like self-inflicted because like I'm making myself do extra practices now, right? But now I'm panicking over not being able to finish the practices. But at the same time, like it's not very urgent. So
Yeah. It's important to do, right? You know,
Mm.
it's important to do. It's probably not urgent that you finish them.
yeah.
It's probably important that you're doing them.
Mm.
Now, I take it that your extra practices are not in a particular topic, but in a breadth of topic.
Yeah.
Good news for you, yeah. Really good news, yeah. Here's a good news for you. I've been reading a book on, the theme is basically breadth and depth. Right? Should we go for a knowledge which is deep, or should we go for a knowledge which is broad? If you can get what it means, lah. Exam is broad, and some of the questions can be deep, fair lah. But each topics are simply drilling for deep, right? And then you change topic and then you drill again for deep, right? So
Yeah.
pretty much everything every evidence I see, because that's how that education and performance researchers do ask this question a lot lah. What must we do in the face of uncertain challenge, right? I think the difficult question of exam is a good definition of uncertain challenge. Right? It's not something you've seen before. It's unfamiliar. I'm sorry, it's an unfamiliar challenge. Right? For unfamiliar challenge, definitely go for breadth. Anyway, you already have depth. Anyway, depth is not the
I
problem.
think so.
Correct. So right now, you're not doing that just an important exercise, you're doing the right exercise. You probably don't want to stress yourself by finishing them because time is still a lot, right? You already know that. And you stress yourself, you are nullifying the advantage of training for breath. I mean, training for breath is supposed to reduce your pressure by making your viewpoint wider, ready for scenarios, ready for many scenarios. Right? If you stress yourself, you are narrowing your viewpoint because stress does that. You shouldn't do that. You should practice with abandon. Just practice lah. Just relax and practice. If you can do it, good for you. Cannot do it, also no problem. You don't discuss with me, good. No discuss with me, also no problem. Just do it lah. Right? You're doing the right thing. Okay? For now, that's what matters. For now.
Okay.
Right? All right. So if that's your situation, anything else you want to share?
Okay, I mean, I got my A-level Chinese results back on Friday.
Last Friday, okay.
Last
How is
Friday.
it? How is it?
I did a lot better than expected. I was only expecting like E or S because I really didn't do anything for Chinese, but I got a B. So
Oh,
I think I feel slightly more pressure now actually because like Chinese is my worst subject. So for A-level, I don't think I should get a B for any subject, right?
no lah, not like
I
that.
don't know, I don't know.
Really, no, really, not like that one. No. It's I mean, it's nice. It's nice to want. It's nice to want a good grade. That's probably what you should strive for, right? Okay, but confidence has no relationship with performance, right? Right. I mean, sorry, what you're saying is something like this. Oh my goodness, because my worst subject is now a B, which is a very good performance, right? I should have more confidence for my other subject. I mean, yeah, that's how confidence works. It works by past performance. But the way you think, you're turning that confidence into a source of, it can be a healthy pressure, it can be an unhealthy pressure. Right?
I mean,
By
I
the
don't want to
way,
be too complacent either, like what happened during O-levels.
true. But you're not doing that. How do we know? How do we know? Because you are getting ahead, not in a way that gets ahead. Sorry, that's a very bad way of saying it. In terms of every topic, you are discussing them in a timetable that I think is appropriate. So happens that the timetable seems to be getting ahead of the class. It's because the timetable of the class is really bad for performance. It's really bad for understanding. I'm just resetting that timetable in an appropriate way. Oh, you just have this lecture, you should be doing this tutorial. You're just slightly ahead from that point of view.
Actually, I'm very
From the point of view of the tutorial schedule, you are.
yeah.
But from the point of view of, I don't think people are supposed to study one thing and do tutorial for another thing. From that point of view, you are not that ahead. You are just normal lah. Okay, quite okay lah. Quite okay lah. Quite just very slightly ahead. Of course, you are very ahead from your classmate if they follow the formal schedule, which is already ahead from other students who are not following that schedule. So you're way ahead. Yeah, but that's not a good standard. The good standard is, what is a healthy learning situation? What is a healthy learning situation? Yours is a reasonably healthy learning situation. So we don't call it ahead, we just call it normal. Good for your performance, good for your understanding. So you're doing that already. Okay, good already, right? You're doing deep training properly. You're also doing breath training properly. That's it, look. There's nothing else to do. Really, no. You're doing this long before there's exam pressure coming in. Then I can speak to you calmly in a way that doesn't pressure you, or if you have some problem. And people can be very fragile near exam if they know they're not prepared. Very difficult to fix problem at that point. Very fragile, you see. Discuss a problem, go panic. Discuss a problem, do something else. My goodness. Now, you're going to be okay, right?
Okay.
You're going to be fine, right? You're doing the right things. You are. Okay. Now, regarding your Chinese to it, I mean, result from one subject doesn't transfer very well to another subject.
That's true.
So, if your other subject gets A, it is not on the merit of Chinese. You don't think that way, you're wrong. But internally, you know what? Chinese is just different from math. Obviously, what?
Yeah.
Just hard work doesn't cover, just one hard work doesn't cover or doesn't do justice to one of the subjects. Math has to be like this, then chemistry has to be like that. Even though the exam techniques are similar, reading first, but the knowledge required is different. Yada yada papaya. You know, I'm saying things that you already know, right? So you don't see things that way. Don't do it that way. Don't. That's wrong. Knowledge from one domain, fancy word, yeah, does not transfer very well to another domain unless certain things are fulfilled. Unless. In A level, you don't even have to think like that, which is a bit sad, but you don't have to worry about transfer. And you shouldn't assume that there's a transfer. You should. Maybe if you consider yourself lucky, and that your Chinese is lucky.
Yeah, I'm already.
Which means you don't want to be lucky for math.
I guess.
That's enough pressure. That's it. I'm thankful for my Chinese result. Gives me some patience, gives me some happiness. I mean, to be fair, you're happy, man. Okay?
Yeah.
So just use the extra, emotional boost to enjoy learning in other subjects.
Okay.
Right. All right. Anything else, Manish?
I guess not.
Okay. Okay. So this is just practical. This is a practical stuff, right? You have responsibilities in the ministry, correct?
Worship, yeah.
Yeah, worship.
I just served today, actually.
You just what, sorry?
I just served today.
Right. Okay. So the appropriate way to handle the responsibilities near exam, because now it's not near exam, right?
Yeah.
Near exam is it important to discuss that? I feel that because if you want to discuss about it, better discuss it when exam is still far.
I mean, I don't mind.
Right. You're already doing all the right things for the purpose of the final exam, right? Meaning to say you are a reasonably prepared person, correct?
I guess.
Preparation doesn't count for everything, right? But preparation does matter. We are told to be prepared in an appropriate way in the Bible. We have to understand what that means. But for the purpose of exam, preparation is not very complicated. It's what you're doing right now. Tada, finish. That's it. Okay. There isn't really much other preparation to be done, right? For ministry preparation, you probably also roughly know what to do. Like maybe not the day before the ministry. Maybe, I don't know, 2 weeks to 1 month, or maybe 2 months before the ministry.
Like practicing, is it?
Practicing is one form of preparation. One form. And of course, preparation must be done because you must work as a team. You are the worship leader. You're not just leading the congregation to worship God. You also have to lead the team. So everybody must be in some sort of sync, right? Something like that. So all those stuff, of course, you need to prepare. The dates of preparation cannot be 3 months before the event. Not the event, the service. It must be 1 week before the service. That's probably the furthest you can go, right? If not, then no point, right? Okay, so I'm not talking about that preparation. That preparation that's just scheduling our time. Talking about
spiritual prep. Is it?
Two things. So the spiritual prep of, I don't know whether the worship leader is expected to be the spiritual leader of the team. I think that's a very big responsibility. So if that's the case in your church, you tell me. In most cases, it's not. In most cases, you have to be responsible on your own spiritual preparation. So I assume that that's the case here. Yeah? Tell me if I'm wrong.
It is.
Okay, then if there's something that bothers you, then we talk about it. Because I'm no expert. I think just sharing helps in terms of spirituality, right? So I won't talk about it too much unless you share. Okay, but in terms of the team, so if your understanding is that near exam you should reduce your ministry, that's your understanding, then there will be a slight vacuum of leadership, so to speak, in the team, that you may want to prepare for that. It's all I'm trying to say. If you feel that you should be engaged normally, probably not more than normal, probably not. I don't think that's the right response. Right? But you just want to engage just per normal. Also, that requires some preparation. Yeah, come in. Right. So that's all I'm trying to say. Depending on what you feel needs to be done, there are slightly different things to be done. If you already know what to do, no need to discuss. I'm just trying to eliminate potential conflicts lah, near the exam. That's all I'm trying. Like, when I say conflicts, I mean self-conflict, you know. Am I supposed to do this or am I supposed to do that? This kind of thing can be thought about like long before, you know, the kind of thing.
I mean, I did ask my leader about taking a ministry break before, and she said it's okay lah, like from June, July onwards.
Up to end of November.
Yeah.
Right. If that's the decision and you already communicate and things are going to happen that way, right? And that seems to be a totally fine situation to me. That seems to be totally fine. Right? Spiritually, I think the answer is very simple. Oh, you're taking a break from leading a worship, something like that, right? Okay, that makes a lot of sense, like in general. So you should simply be worshiping by yourself. I'm not sure whether that makes sense. So you don't stop worshiping, something like that.
Yeah.
I
do actually.
That's all. That's all there is to it. Principally, principle. That's it.
Okay.
Okay. In terms of details, we should only talk it out.
Sorry?
No, sorry. If you want to ask a certain detail, we only talk when you ask. I won't ask.
Okay.
Okay. That's all. That's usually the biggest conflict. I mean, outside of time management and energy management. I always assume that your time management and energy management is probably fine under pressure, right? If that turns out to be wrong or you're bothered by something, I think I will expect you to raise the issue. If you want to talk about it, I think you should. That's all. Okay. If there's nothing else, let's go to, so what should we do today?
I'm only gonna do complex numbers, like the 13D tomorrow.
Yeah. Oh, you mean the tutorial?
Yeah, the tutorial. So, and then this morning I marked like 2 of the math papers that I did, and I do have questions up.
Good. Yeah. So let's we'll talk about breath today, right? Not deep,
I guess, yeah.
Okay, good. I don't mind me eating it.
Yeah, it's okay.
Thanks.
I realized I struggle a bit with functions now.
It's been a long time since you asked, so happy to address. Nice, nice. Okay.
Oh, this is the answer. Wait.
All right. Let me ask you about the priorities, or rather the order. What does your school or teacher say about the order?
Like during the exam, is it?
No. I mean the order of transformation. Like some schools say it's AMMA. Some schools say it differently. I don't know. What does your school say? There's a certain order.
I forgot the acronym, but it's like translation parallel to X, scaling parallel to X, then scaling parallel to Y, translation parallel to Y.
Yeah. I understand. So you know that. Okay, I understand. Now, what is the question therefore?
I don't understand the answer. I don't. I cannot like.
Of course.
Where's my? Okay, maybe a bit rusty lah, but yeah, I can't get what they say.
Right. So I don't know. No need to show me the answer key. You can see the answer key by yourself. No need. It's okay. No need to write. You just see your answer key if you want. Right. Okay. I'm gonna erase it. Okay. Wait. Remember, in this position, it is important for you to know that I do things like I do in exam.
Okay.
Which is to say, I don't know the answer. Which is to say, whatever I say draws from some sort of principles.
Okay.
You don't want the answer key to influence my answer. That's exactly what you do not want. Right? Not when your goal is A or something like that. No. If your goal is C, heck care, whatever, right? Do whatever it takes to answer like the answer key. But that's not an A student. That's not a student with understanding, so to speak. Okay? Right. So keep it that way. If I'm wrong, you can at least learn something.
Sure.
Right? If I'm right, then hopefully you will learn something. Right? Right. So I see this question. Okay. I mean, I don't know. I'm comfortable. I guess I'm a bit comfortable from simple to complicated, easier to see. I don't know. Some people cares about that, right? Okay. But I feel that I'm a bit uncomfortable with the X above. And there's no X here. So what's going on here, right? What's going on here? That I believe is the important thing to solve. What's going on here? How come there's an X? Because there's no transformation times X. There's no scaling times X. Everything is times a constant one. So it bothers me a little bit, correct? Bothers me. And I decided to try to solve that. That's how I think, basically. Because the rest, I feel, is quite easy to solve. Like, it's obvious how this becomes that, just times minus, right? Okay, I know. Right? But this guy is the important thing. That happens in my brain in around the first 5 seconds. That means I'm reading already. Oh, what am I supposed to do with this? I feel this is important. Then, based on experience, I draw, the fact that actually you cannot just appear, an X cannot just appear on top. Cannot be one. Because there's no transformation that involves X. So I decided to I decided to long division.
Long division.
Because
like
long division,
the second one.
Like division, the second guy I will division. Because I believe that will get rid of the problem of having an extra X. Because there isn't supposed to be an extra X. Cannot be one. Okay. So watch me doing it, right? Of course, that's a theory, right? Remember? Oh, it's a difficult question. Let's consider that way. So I must test my theory, right? Let's see whether it will help me reduce my problem. I'm trading one problem with another problem. Hopefully, the new problem is less. So this will be my mistake. Correct? Correct? Make sense?
Yeah.
So now, therefore, this becomes what?
-2. Yeah.
All right. I'm trading one problem for another problem. That's always what difficult question we're supposed to do that. Usually we're supposed to do that one. And you trade this problem with a problem which is, well, less of a problem. So what do you think? you have no idea.
Actually, yeah, this could work.
Yeah. And therefore, if you feel that you want to practice more, I should stop here. No? I should stop here. Because when I say division, you don't seem to know what's going on, but then you see the result, you seem to be more convinced. So can you try this? So everything is y lah. That's what you're saying, right? I
Yeah.
would probably agree with you. Probably. Yeah, probably. Anyway, you have the answer key lah. Now you can check.
The first
order
one
seems-
supposed to be x-axis. Yeah. But
the first one is x-axis. It doesn't
but
seem to
then
make
the
sense.
-3 will be a problem.
Yeah, what? It's the negative of everything. What? Yeah, that doesn't feel right. If you just negative by the x-axis, it'll be negative x. No, he's correct. No, he's correct. The phrasing should be reflection of the x-axis.
Oh yeah,
The
sorry.
phrasing.
Okay.
But the reality is you jump on the y side. But the
Yeah.
phrasing sometimes.
Okay.
I think the
Okay.
thinking is correct, but the phrasing is wrong. Yeah, I missed that also. But remember, yeah, your concept is correct, lah. I guess.
Okay.
Mm.
Yeah, the answer key didn't mention the partial fractions thing at all.
No, don't call this partial fraction. This is not one fraction
I
in
mean, it's not. It's division.
division.
Yeah.
Yeah, but the division seems to be the most important part, lah. The most important conclusion from reading, I would argue. Since the answer key doesn't show, you can be convinced, kind of, I suppose, that what I'm thinking is a productive way to think lah, in exam. So your confusion is correct. But usually people are confused by their confusion. I didn't react that way. I think that's the right thing to do. Or I'm supposed to be thinking about this problem. Okay. You shouldn't have the Pikachu surprise. Shouldn't. It is the right problem to consider. Okay.
Okay. Oh, okay. This is a more general question.
Mhm.
Hang on. Let me. You know the MF26, right? The integration formulas. Okay.
Sorry, are you putting something right?
Yeah. MF26. Like for example, I'm using this, then it will become like this.
Mhm.
I thought the coefficient of x must be 1. then
This
I
is
can
the one
apply
without
it.
fx, right? Because if it is not 1, you can apply using the fx one, no? The reverse chain rule. I'm sorry. Right. What happens if it is not 1, right? That's your question, right? What happens if it is not 1? Because I think it's very likely for that to happen, right?
Yeah.
Is that your question?
Yeah.
Okay. Oh. The random. Great. Now let's make our life difficult, right? Okay. So how to set up, right? Now, of course, we should follow the form as easiest. So let's see whether we can do that, right? Gonna ignore the integration. This is not on my mind, right? Let's just ignore that, right? So my focus is to make this 5 into 1, so I guess that's not very difficult to do. If you want to do that, go ahead. Just do it. If you know what to do, just do it.
So I think I have to take this out.
You can take the 5 out. I will go as far as take the 3/2 out also, because I can,
Yeah.
right? Because it makes my life easier. I'm happy to do that. At this point, I don't think there's much problem, right? The 7/5 just square root, right? Square root.
Oh, so it has to be 1.
Oh yeah. To answer your question,
But how? Okay.
Yeah.
But I've seen 2 questions already, right? They like something like this. Then it becomes this.
There must be something else here, like 1/p or something like that.
Yeah, there was a 1/p. So that matters.
No. The 1/p is below.
Oh, below.
So let me explain. I just put something here, right? I'll explain it in the easiest way, if you can accept it, maybe you just.
Yeah. Sorry, 1/. Yeah.
So that means there is something going on, So that means oh, but you're confused. What happened if you take out the p? Okay, I understand. So I will treat this way slightly differently, because this one is paramount. So I cannot take the p out. If I take the p out, it will affect the 1. So what am I supposed to do? Well, I will just view this as fx. Correct? I'll just view the fx, a very simple fx. And therefore, I can just let me demonstrate another way, easier way. So what happens if I differentiate sine inverse px, right? That's probably the easiest way to explain, right? So what happens? Good. Yep. And then times f prime, right? Yeah. That's the reason for your 1/p.
Oh, okay. So they.
That's all.
So they just like.
Yeah, a very minor correction. Yeah. There you go. Something like that. Yeah. If you want to see it that way, okay, can also very good. It's very good also. Yeah.
Oh. Okay.
If this makes sense to you, good. That means it's a minor correction. Right? It's a minor correction on a reasonably okay answer already. I just need the 1/p.
But it doesn't have to be coefficient of 1, right?
Oh, that means I could use this exact same thinking in the answer above, right? Because the situation is different. So I'll use that.
I mean, the 1 doesn't have to be 1, right? It can be.
So the 3/10, right? The 3/10 is a product of
Sorry?
I'll put it another way. So I can erase this. Yeah? Is this? Let me erase it. Let me put it another way. It is an important question to ask, right? So now try to integrate this first. So integrate this, integrate that. Okay, integrating is probably easier, so let's try integrating this first.
Integrate.
Because our original question is to integrate, integrate this one. Okay. With the 3/10 in front, right? So I will now transform the guy inside into root over 5x over root over 7, something like that. That'd be okay. All right. So let's see what happens if we don't reorganize. If we don't reorganize and we just kind of whack from here, so to speak. Okay. Okay, so what can we do? Oh, I'm very confused about this 5x, right? Okay, what am I supposed to do? Well, first of all, I'll take out the 3/2, same thing, right? So I will now be integrating 3/2, just to give me better view of things, right? Okay. I'm still worried about this 5 because this is x. Currently the A should be, oh wow, this is good. Oh no, but correct. So 1/a. So let's pretend that this is A, correct? This is A squared, correct? So 1/a with 1/7, correct? 7. And then I'll have my tangent inverse, correct? In this case, because this is like my x squared, so I have to assume that this is, this is my root 5x, correct? Root 5x over A, which is root 7, correct? So far, by this simple application, which is most certainly wrong, right? It is wrong here, but as you can tell, it is most certainly wrong in a very minor way, right? Just like the one just now. Remember the one just now? It was wrong by 1/p, correct? Yeah. How do we discover that? It's very simple, if this is like the laziest way to do integration when you suspect a minor problem, not a major problem. You just differentiate this guy back, and see what's the problem. And then you just fix it that way. Really, really that simple. So try that. Try differentiating this because you assume that it's going to be wrong in some minor way. And then just discover a way to fix it. Right? Give it a try. See which one you like better.
I don't think it's gonna be the same.
No, of course not, but we're expecting a minor difference. We're not expecting a major difference. So the problem here is, right, you're trying to make it as similar as possible, right? As similar as possible. Wait. Are you doing it correctly? You're differentiating. Oh, goodness. Your differentiation, you forgot something. You forgot a chain rule. You're supposed to have root 5, root 7 here. Nope.
Yeah.
Okay, so, right, let's try that. Which you want to simplify the 7, kind of. So the root 5 can stay outside. Good, the root 5 can stay outside. The inside is going to be 2 times 7, because the 7, you're going to put it in. 7 you're going to put in.
2 times 7. Okay.
Yeah, leave the 14 as 2 times 7 because the 7 will go in 1. Confirm you will go in 1. Right. Yeah, confirm 7 you will go in. Yeah. With an excess baggage of root 5 outside, right? Why is it 1 over root 5? It's actually root 5, not 1 over root 5. The excess baggage is the root 5. Right? So as you can tell, a very minor difference that is easily corrected, right? That means your final answer should have been this guy with another 1 over root 5. You know, something like that. To correct for that. Wait a minute. Wait a minute. How come that doesn't seem right? Let me check for one. Let me check for one. How come it doesn't seem to be the same as this one? Oh, it is. It is the same. It is the same. Because this is 2 and this is 10. Oh, it is the same. No, it is the same. If you're confused, you tell me. It is the same. It is the same. Sorry. Let me just make it very clear. So this is equal to 3 over 2, right? Root 7. Sorry, root 7. Hello, Daniel. Yes, I can hear you. Can you hear me? Right. Yeah, that's the 1 over root 5.
Yeah, can hear you.
Can Keiko? They're exactly the same answer.
Okay, so I can just like this is the differentiation, integration,
right.
And then like the coefficient, I just like square it.
The coefficient, you just square it. The coefficient.
Like the.
No, don't work out a general principle. I'm serious. Don't work out a general one. Just either do what I did, the rearrangement, so that you have no doubt, or you have doubt and then you go and correct it by simply differentiating. Don't work out a general principle. Don't. Because then everything is different. The general principle is slightly different for everything. Then it becomes very confusing. Do you understand? Oh, you have to root this guy out, but that doesn't work for the sine one or something like that. That doesn't work for the ln one. It's slightly different from each. You don't want to suffer like that. So do you understand what I'm saying?
Okay.
Right. So either you rearrange until there is no doubt. That's one way. Or you just, so to speak, anyhow integrate and then differentiate back to correct. You do either one, but not some sort of generalization.
Okay.
Yeah. You can if you want to, but doesn't seem to be helpful when things are hard. Doesn't seem to be like that's what I feel. Intuition in this, you have the freedom to do what you want. Okay, so I'm just telling you what I feel is best, but you can experiment. Okay, yeah. Don't be rigid, okay, yeah. Don't be rigid. Don't be rigid even with what I say. Right? Don't do that. Okay. So Daniel, right? Okay, I hear you just now. So today you want math. Totally agree with that, right? I agree. Shall we go to the previous Jamboard? Okay.
Sorry. Is it okay if I share screen? Or?
I can see your screen. I have no problem with that. Good.
Sure.
Your Jamboard should still be Daniel Math.
Yeah.
Right. So just roughly so what have update me on something. Update me on how you are.
Okay, so I have a test on Wednesday.
Okay.
It's on differentiation, limits differentiation and application on differentiation. So it's 5.1 and 5.2. Maybe
so
today
no
we do
integration.
5.1. Yeah,
no integration. Good.
None.
Good. Happy to know.
Today we do 5.1. And Tuesday we do 5.2. Is that okay with you? Or?
No problem. I still don't want to do the L hospital unless you have an objection on it.
Yeah, how do I do 3B? Okay, let's start here.
First principle, first principle. Hey. I'd rather discuss the application with you. Now,
We can make up our own questions as long as there's like for this is I think 3 things you need to cover is first principle, L'Hopital's, and implicit. These are the 3 things you need to cover.
You mean the rest you're okay? Yeah? Are you sure? Because this doesn't even have application, and application is usually more important in exam, not the basic stuff. I'm a bit worried
Sure.
here.
And
Right.
if you look like you show the
I'm looking at it.
yeah, there's always all the questions so you can just pick and choose which one you want to do. They all come under different standard functions.
This is not 5.2, right? This is not 5.2, right?
This is all 5.1.
Can I see 5.2 first? Can I see that for?
Okay.
Sorry, Keiko just did it. Yeah, this sounds like application. Good. So what about the questions? Show me the questions. Yeah, nice, very good. Sure, whatever. Yeah, nice, very nice. Everything good. Now, okay. 5.2. Let's see. Yeah, okay. Moving down. Thank you. All right. Nice. Moving down. All right.
What, 19 questions? So long.
Right. So I warned you, right? In the locals, the application is vastly more important than the basic stuff. First episode are basic stuff. That doesn't mean it's easy. Basic doesn't mean it's easy, but even the examiners will focus more on the application. Because application, really. And discussing 19 questions is probably more beneficial, and I don't think we can even do it in 2 sessions. So we really have a big time constraint. Right?
Okay.
Now you're the one that makes decision. Really, Daniel. You have to make decisions based on what you think. I give you the information, meaning to say, I really think 5.2 is going to serve you much more, even at the cost of 5.1. I mean, all of 5.1. Like we don't care about 5.1. We just discuss 5.2. You will still get more benefit out of it. That's my opinion. You will not be able to do everything. You don't mistake my word, sentence. You cannot do everything if you ignore 5.1. But if you ignore 5.2,
yeah, okay.
That is going to hit you like triple punch, boom.
Okay. Well, how about we choose a few questions from each of the sections? There's one tangent normal, and there's one maximum minimum. We'll just do all the start questions.
No. I want to see you do question 1 first. Question 1 is already not very easy. Can we do that? Okay, try question 1 first. Give it a try. I'll follow you. Keiko, what's the issue?
I mean, I don't understand the answer key also, but yeah.
Oh, this thing again.
Yeah, this thing again.
But they do like it. Hey. Okay, it's nice for them to give us the graph. That's nice. Sorry, whatever. Daniel, mistake on line 2, please. Mistake on line 2.
Oh, sorry.
It's nice for them to give us the curve. So are you saying that part 1 you're okay?
Yeah.
Oh, that's nice. Okay, good. Therefore, you integrate, right? Lah. Oh. Okay, wait. The integration is easy, right? So can you integrate? So where is the result of the integration? So I don't. This
Oh,
this
this one,
is
this one.
this is the definite one. Ah, okay, okay. Nice. Just check. Yeah, that sounds about. Wait. Let me just check. Right. Let me just check. So minus x, right? Okay. And we'll put it minus n. Yep. Then plus. Hey, what? Sorry, I think something is wrong. Let me check. Oh no, you're correct. No, you're correct. Absolutely correct. Good. Okay, so we got that. Hmm. Oh. Right. So, um, product rule seems fine. Then you.
Can I just say this?
Okay, go don't wait for me. Yeah. Can you directly say that without this, like some sort of justification, right?
What else can I do to this?
Um, well, I don't think so. I don't think so. I don't think you can just say that. It's because it's not at least obvious. I would say it's not obvious, if that makes sense. Right?
Mm,
Why would they want to prove? And then what's the connection between the second guy? Okay, you leave it like that first. Do the second part first. We'll come back to part one. Okay, I have to quickly finish something. Right? Okay. So
yeah, I think I can. Hmm. Hmm. Huh. Oh. Oh. Wait. Wait. I thought a different way. So you get 3x squared over 2x minus 2 over 2x. Then you can just cancel out here. Cancel out here. So
that's
you
a
get
much better.
3 over 2x minus 1 over x.
Yeah, that is a much better way. Yes, thank you very much. Thank you. That will make your difference much better. Good. And then you have the 3 over 2 look. Yes, nice. Nice thinking.
Just be 3 over 2.
Mhm.
Oh, plus 1x squared. Mm,
Oh, okay, I understand.
Because
I
I
was
saw the
wondering
one
where
also,
the
yeah, where does the one
yeah.
come from there?
oh,
I think it's a reading issue. It's a reading issue, yeah.
Okay.
Because I also missed the one because it looks, it looks hidden, right? Wow, nasty, right? Nasty. But you have to look for it, lah. You have to learn. Lah. You have to learn. Ah, there you go. Wonderful.
okay.
Yes. Nice. Good. I mean, then the equation of normal is just, let me just see it once, lah, then you're okay. Question 2 will be implicit, lah. Implicit, lah. But not a nasty implicit.
Uh, hmm.
Are you okay, Daniel?
Mm,
You have to find the gradient of the tangent first. You cannot go directly to normal.
Isn't this the gradient of the tangent?
Yeah, you have to put in the half lah. Because at x equals to half lah. So you can find the gradient of the tangent at half. There's a at half there is very very specific there. Careful.
Oh, I didn't even see that.
Sorry, Kiko, are you putting some new thing? There. Kiko, I'm going to say something quickly. See whether it makes sense or not. It's a quadratic, right? Nothing fancy with a quadratic, correct? However, a quadratic is not one-to-one.
Yeah.
There is many to one, right? So our issue is always to make the quadratic into just one-to-one, and therefore one of the ways is to limit the range, limit the domain. Just cut it basically. Right? So you're finding, yeah, good.
But
so I don't know. You're saying? You're saying?
Actually, okay.
Yeah, you're
wait.
doing, yeah, you.
Okay,
I suppose.
I mixed this up with another question. Sorry. Wait,
yeah, this is not very difficult. Looks great. Looks great. Yeah, looks great. You have to find the C lah. So how?
Find the x and y value.
Yeah, you have the x value. You need the y value. How?
X equals half.
Yep, nice.
So you just use fx.
Makes sense. Does that make sense? Not dy dx lah. Y lah. You're copying error, right? You have a problem with that. Okay, be careful then. Yeah, be careful. All right, good. Okay, still quadratic.
Yeah, this one is the coefficient. This time.
Right. Which is weirder, I agree. Now,
Yeah.
What is this? Sorry, what is this?
Actually, I don't know. I was about to ask you also.
Okay, but he gives the limit of a domain, limit the domain, correct? That's a normal, it's a normal strategy employed because quadratic looks like that, and this is many to one, and so you always cut them somewhere here, correct? Somewhere here, because if you don't cut somewhere in the, you don't cut on the maximum minimum point, then no point, right? Something like that. If that makes sense. Now, however, the limiting the domain can also be something like this. So, ting ting or ting ting like whatever lah. But the furthest you should cut is the most effective cut is this one, right? Okay. So maybe that's what he wants me to do lah. Maybe he's asking us either make this point or make this point. Maybe not. Maybe that's how I can interpret it. That makes sense. That makes sense because the most effective cut is on the maximum minimum point anyway. So maybe I'll start from there. Yeah.
That's correct.
Looks good. The Y looks yeah, the Y I don't know whether it's correct or not, but it looks kind of good lah. It looks kind of good.
Here, I got my calculator.
Correct.
think
Correct.
we
Better.
need
Yeah, better. Right? We don't have to trust ourselves for mental calculation. We don't have to. Not yet.
Okay, so I'm basically looking for a turning point, right? Then I should do the complete the square also.
No, you're not looking for turning point. You're already assuming that 7/4 is the turning point, or 5 is the turning point. I mean, half of the turning point, the x of the turning point.
Okay.
With that, you can probably find lambda, right? Probably. Give it a try. How is it? Sorry. By the way, do you have the answer key? This is the time to use answer key.
Yeah, it's right below.
Good. So you can check the calculator, but more importantly, and to save time, just check the answer key. Really.
Okay. Therefore, when -5/6 equals C equals -5/6.
Yeah. So Keiko, I'll probably try this direction. I'll probably start from here. Probably. If that
That's
makes
a
sense.
very wrong answer.
Which one is wrong?
Wait, I didn't do question 1, right?
I think so. Yeah. I mean, it
Find the
doesn't
equation
seem
of
to be
them. This is the answer for partners.
Yeah. What the heck is that? Well, that does look kind of like a line. I mean, it can be. Oh my goodness, he doesn't tell you anything else. Because the y is negative, right? But I don't think you can get this from that. Look, I'll check the false. Right? You do the next. Let me copy this.
Wait, sorry, what's this? Why what?
Okay, just a minute. Let me copy the question. I'll explain to you. Okay, you do question 2 then. Question 2 is also not to be skipped because that's probably an implicit differentiation, something that you want to practice. Okay. So instead of starting from this and forcing it into completing square, right? If you like it, I'm okay. If you like it, I'm okay. I would actually start the other way. Look, I already know the x of the maximum minimum, so I put it in the completing square form, right? Put it in the completing form. I'm sorry.
The implicit differentiation.
What? You did question 2 just now like this, very fast. What?
I did beforehand.
Oh, goodness me, you did. That's so nice. Can you do the second part of the question?
Sure. Let me try.
What is that?
So, Keiko, isn't this the completing square form?
No, wait, what is this? What I cannot read.
Oh, I'm sorry. Y minimum. I mean, I don't know the Y minimum.
Oh, why minimum? Okay.
Yeah, the Y of the minimum, which I don't know. I don't know. Right. I just acknowledge I don't know, and I don't think I can find it. Right. I mean, I can find it in terms of alpha. I guess that helps. Right. Yeah, I suppose I can find but my point is just compare this guy, expand it and compare it with the original form. Also can work lah. Wait, how many questions have you done, Daniel?
Just two.
Oh, still nice, still nice. Still good to know that your implicit is quite okay lah at this point. Still nice. I mean, at this point, you know the alpha already, right? If that's what they want you to find, you already know the alpha. You don't even care about the y minimum. Correct, Keiko?
Oh.
Right? Just by comparison.
Oh, then should I sub 5 in here also?
Yeah, I just sub 5 and find another alpha, and hopefully that's correct. I mean, for 2 marks, that seems to be what is, that seems to be the effort that we need. It seems about. But of course, check that. Oh, goodness me. So, Daniel, look at the, later look at the Jamboard, okay? Look at the Jamboard. Oh, goodness me. I found your mistake. Fine.
I look now.
Later. Sure, if you want to.
16, right? Page 17.
IP 17. That's alpha, Keiko, not X, yeah?
Okay. How's it?
Right. Whereas the range, I'm not so sure, is between 7 and 14,
Sorry.
limiting for 1.
Yeah, it's supposed to be 20.
Right, 20. But is it between 7 and 20, or is it the other way? I'm not so sure yet. Oh, but it looks about right, because that means our x can be between this number, right? So for example, if I take a number 4, right? For example, 4, and then I will get 8, right? As a result, right? If I put 4, I will get 16, right? 16, right? If the x minimum is 4, I'll get 16, and 16 is definitely in between 7 and 20. So I was just checking whether the range is correct.
Okay.
That makes sense, right? Okay, this should be the answer, but please check the answer. Okay, Daniel, do you see the mistake?
No.
I don't think it's a conceptual error. I think it's a careless mistake. I think you're just being careless.
Was it plus?
Oh, goodness me, you don't see the mistake. Oh, okay. So looking at our mistake is always the hardest thing, right? Okay. Me finding your mistake is no big
No,
deal.
like you have to put I put the wrong sign. Should you have plus 1
No,
over
you're
half?
still wrong. You're still no, you have to see your own mistake. Come on. Seeing our own mistake is difficult, right? It's easy for me to see your mistake, right? No big deal there. But you, oh, come on, see your mistake, man. Oh. I cannot tell you.
No, there's no half there.
I cannot tell you. What kind of mistake you could have made if your top 2 seems to be correct, then suddenly you are wrong, right? What kind of mistake? Oh, just find it, man. I don't know. I'm not trying to make your life difficult, but you gotta see your own
Wait,
mistake. Man.
Isn't it this? Here. This there's no x, so there should just be 3 over 2.
Do you realize what you
plus.
use? You use the y, you know? Oh my goodness. You are slow. You use the y, not the dy dx.
What do you mean? Yeah, I know. So I'm saying I should have used the dydx. No, that's my mistake.
Yes, not the one. Yes. Oh, if you see that yourself.
Yeah,
Yeah,
that's
yeah.
what I meant. That's
Correct. Wrong.
Okay.
That's why it's wrong. Just try to fix it first. Or you know what? Never mind. This is rare, but I want to cover as much as possible. Right? Never mind. The concept is correct. Doesn't mean that you will make no careless mistake in exam, but just fix it later. Okay? Just fix it outside tuition. Okay? Fix it outside tuition. Let's use tuition time for something better, like covering a lot of times. Yep.
How do you find 2 points of the curve?
2 points of the curve, such as the normal
Parallel.
the curve at these two. So fast. So they are telling you that the normal is parallel to the y-axis, meaning the gradient of that normal is infinity, right? Infinity, which means the tangent at those 2 points, the gradient is
0.
You must think that way, like they're telling you something in a very roundabout way. On those 2 points, the gradient of the tangent is 0. Very roundabout way of telling you. But if you don't read it that way, it's difficult to use that. Sorry, Kik. Did you start something? Was the previous question correct?
Yeah. Oh wait, no. That's just. It's supposed to be more or equal to and less than equal to. So that's the line underneath lah. But why?
Wait, let me think forward. Huh? Why? Wait.
Also, I was trying to visualize it because I mean I just copied like this form, but then I can't really visualize it also. Isn't it supposed to be?
I have no idea. Let me think about it. Don't wait for me. Let me think about it. I have no idea why. Let me think about it. Your dy dx, right? So how do you use that information, Daniel, when it is implicit? How, right?
Do from here lah.
Just use the dy dx as equals to 0. Just whack it. No, don't find dy dx. You don't have to. Just whack dy dx equals to 0 and see what happens. That's the logic of implicit. Whack it first. Put in 0 into the, yeah. That's 0 already, right? It's nice. Minus 2y, not 0, and then plus another 0, right? I know that's not the way. What? How come there's a z there? I'm sorry. What is that z doing there?
That's an x.
Oh, it's an x. I'm sorry. Okay, that's also a 0, which is nice, right? Equals to 0, right? So you get something out of that, right? Yeah. Equals to 0, which equals to 0, right? Which you kind of get something very simple and nice.
Okay, so once you have 2x minus 2y equals 0.
Simplify further, Daniel. Simplify further. Simplify further. All right. Now, this doesn't give you a point, but it gives you an equation to use. This is weird, but this is a very useful result, not a final result. Can you accept that? You are to use this to find a point.
2 points on the curve.
Because you have to find the point. This doesn't give you the point. You expect dy dx equal to 0 to give you a point. You got to find that tendency in implicit. Instead, you have to say, how am I going to use x equals to y to find a point?
Okay, so I use this equation? I sub x equals 1 to here. Highlighted.
Not the equation of normal. Most definitely.
So
I don't
should
think the
pay
equation of
attention to-
normal, let me think. Yeah, no, I don't think you should worry about the normal.
But because we're looking for the
Wait,
normal,
why
which is
why do you? Oh, yeah, they do ask you to find that. I'm sorry, they do lah. To be
Yeah.
fair, they do lah. Yeah, but that's the equation of normal at a 7.3. That's why you shouldn't use it,
so you're asking for 2 points on the curve, so I choose the curve.
which is not 7.3. You shouldn't assume like 7.3. That's why you cannot use that.
So I just use this.
Yeah, the original curve. Yes, exactly. Just use that. Exactly the point. It will feel weird though, but yep, that's what you use. Oh, new question. Okay, good. You're saying that your problem is part 3, okay? Right. Yeah, not sure what similar form is. Okay, go
As
by.
in like this lah.
I suppose that you
Yeah.
just what
That's why
call this, split the function, right? Okay. I guess you can do that. I guess you can. I mean, G, this is not G squared, this is G of G, right? So I guess you can do that for the two functions. I guess.
Okay, done.
All right, is it correct?
Yep.
Any question on logic?
No.
Right, the logic is what you need.
No.
The logic is
The
what you
whole subbing is kind of dumb too.
need. No, it's not dumb. It is. Oh goodness me. You're allowed to
It's
think that it's dumb as long
annoying.
as you can do it. You're allowed. You're allowed. But if you think it's dumb and therefore it stops you from doing it, that's bad. So for 3-star, it's rather obvious that it's gonna be implicit. So you will always have a weird logic flowing around during implicit. That means after the implicit differentiation. Do you feel you need to practice one more?
Yes. I would
All right.
like that.
Right. So 3-star. Right? Yeah, this answers the question of how strong your implicit should be. If this is the strongest you should go, I'm quite happy. I think you can ignore the 5.1, really. I think the problem is not the implicit, but what happens after the implicit. I think that's your exam. I think. Taking a bit of risk here, yeah. I'm predicting your exam, yeah. Prediction is never accurate, right? But that's the risk, lah. If you do not want to take the risk, you can just help. It's okay. Good. Okay, good. That's fine.
Okay, basically, right, the answer key split up this function, this part of the graph lah, for the G square. So there's
Is concerned with the logarithm function, right?
yeah,
Correct.
then there's
The quadratic one probably not. Yeah, I will agree lah. I will agree.
oh, but I don't understand why lah.
Yeah, you have to see the G square form or the GG form first. Try the GG form first. What happens when you G in
For
G?
both
Yeah, try G in G first, and maybe you will see the need lah.
Wait, which one do I?
When you
do I just-
sketch, wait, when you sketch, wait, the sketch is from you or the sketch is from the answer key?
From me. But yeah, it's correct lah.
How come you pay attention to the root 2? Sorry, what makes you pay attention to root 2?
Oh wait, no, yeah.
What compels you to pay attention to
Oh
root 2?
yeah, sorry. So this part is from the answer key.
Correct. So
Yeah.
we don't have any idea why you should be paying attention to root 2, right? Currently lah, and why? So that's part of that is your question. So try the G form first, right? Why are you concerned with that, Daniel?
Do by parts.
By part.
I
by
split it.
part.
No, how do you say? So what's the product rule? Product rule. Sorry.
Yes, product rule. Yes. Yeah.
Yeah.
Yeah, not by parts.
Because I did it together just now, and I was
Correct,
like,
correct. Yeah. Oh, yeah.
oh.
dy dx. Typing error.
Okay.
Come on. Writing error. Come on. Okay. Well, that's confusing. What are you supposed to do with this? Let's fix a few things first. I just
Wait,
fix some. Oh yeah.
Okay, proven.
Good. That's the easy part. Therefore, your implicit is more than enough, right? Skill. Now the problem is afterwards, lah. So I believe, Keiko, the split is between this is I mean smaller than 1, so still positive, right? But smaller than 1 and bigger than 1. Why is that important? Because the outer 2 log 2 log 2 smaller than 1 will give you something different than 2 log 2 bigger than 1. I'm sorry, bigger than. I'm sorry. No, bigger than 1. I'm sorry. Oh no, it is more than 1 and bigger than 1.
wait, what?
Wait, what? Wait, am I saying it right? Never mind. I'm just going to draw.
What do I do here?
Yeah, sorry. Yep,
Trying to find.
Okay, right, okay.
So I'm trying to find the equation of normal, right?
You have to find the normal at P and oh my goodness, normal at P and normal at Q, and then you cross them, then you cross them, right? So you have your divide X. Yeah.
What do I do next? I have to find C, right?
No, first thing first, for the gradient of the normal, you can use X equals to 1. That will simplify your life, right? A little bit, just a little bit.
Oh yeah.
Just a little bit, but we use everything we have, right? You brought the tool, yeah.
Is 5 plus 2y plus 5y. Okay.
And you use you find the y coordinate of P and Q from the original equation. That makes sense.
Oh, there are points on the curve.
Correct.
Oh,
Which I want to find if I can. I mean, that's still our instinct. So I think we can do that. We can do that. We need the y coordinate, and therefore your gradient is solved. Right. So that makes sense, I hope. Like I said, the logic becomes more convoluted because you have a y. That's what I'm trying to get you used to. If I didn't say that, would you have realized that?
I don't think I read the question properly. I didn't realize that they were on the curve, which means I can use this fx.
Okay, I guess read properly, but that's important, right? That is important. All right, give it a try. Equal, oh, we have 1 minute left. Yeah, I think we can skip everything here.
Oh, this can't be simplified. Yeah, it can't be simplified first.
Iya, kan dia makan di dalam itu kandang babi. Itu di yang hilang. Tapi kenapa sih ya kayak kita akan memakai.
Oh, it's not equals 0, it's equals 2. Oh.
I'm still thinking. I cannot explain today, but I explain tomorrow. How much do I owe you? Right? I owe you. Oh, I only owe you this one, correct?
That's the previous one also, actually.
Which one?
The
The sign. Yeah. The why
actually, it's not just the sign. It's supposed to be
Hi, Kirana, I can see you. Yeah, can you hear me? Kirana, I can see you. Can you? Oh, Kirana, Arya, you're in. Good. Kirana, you moved it, I think. Kirana, you're muted. Arya, can you hear me?
Yes, I can hear.
Good. All right. Kirana, can you hear?
Yeah.
I see. Okay, go. Yeah, I'll you 2 things.
okay.
I'll see you. Bye-bye.
Okay, bye-bye.
Arya and Kirana, as per usual, start with a new Jamboard. Duplicate, give me the update. I'll read your updates, and then we'll go directly to your question. If you forget how to duplicate or anything, just tell me.
What is the question asking for?
You already found P and Q, right?
Yeah.
So he's asking you, okay, wait, I have to check your reading. I have to check your reading skill. Very important, the most important skill. Find the point where the normal to curve P and Q meet. What do you understand about that phrase? What do you understand? Think slowly, nothing rush.
So where the normal of P and the normal of Q meet.
There is a point. Make sense?
Okay.
The normal is the shape of a line. So when two lines meet, at that point, you probably have an idea what to do. Now, why do you want to find the y? Why bother finding the y just now?
To sub into the equation.
Of the,
So you have like the normal.
yes, the gradient of the normal, correct? Eh? The gradient of normal, not just the normal, but the gradient of normal also need y, which is weird. But no, you sub in the y first to get the gradient first. I think it's easier that way. You want the gradient of the normal first, yeah? That's not how you sub it. You sub in the 3 into the y.
Yeah, my brain's lagging.
Right. Okay, and 3 is not equal to that. That's equals to mn. Yeah? Mn, not 3 equals to that. Wrong. Arya, do you have the new Jamboard? Kirana also do that.
I need to find C first. Oops.
Also true. Yeah, also true. Which you just sub in the x. Oh, never mind. Okay, I have Arya and Kirana. Good.
Chasing that A and want to save time on proofreading? Grammarly makes editing one click simpler.
Oh, wait. Why did I?
Okay, understand. Yes. Yeah. Okay, what? Oh, you're using last week's Jamboard, Kirana. Am I correct? Correct, Kirana?
Yeah.
Oh, that's okay. Okay, never. That's okay. That's totally okay. That's okay. Right.
It would be like feeding a toddler nothing but candy. But you want to know what rabbits actually eat. Rabbits are physically required to eat food, and they do to make sure they get all the nutrients they can out of one meal.
Somebody is giving audio. Careful, yeah. Okay, Kirana. There is no math exam coming, correct?
Huh? What do you say?
There is no math exam coming, right, this week?
No. I already do.
Correct. Now, this is special for our tuition. Only for our tuition.
Guys, I love bread.
Okay, who is playing the video and the video goes into our Zoom? Be careful there.
Anyways,
Aryaf?
Yeah.
Aryaf? Careful, is your video going into the Zoom?
Huh? My what?
Is your video going into the Zoom?
Yeah.
Be careful.
Oh.
Yeah, mute your video and don't watch videos. Probably bad.
Yeah, it's a bit
watch videos. Yeah, don't watch. You can watch it later. So now. Kirana, special for our tuition, yeah. If you have to focus on other subject because of exam, let's just move the tuition to next week. Easy lah.
Oh.
Do you need that for this week's exam?
I mean, I don't have math exam this week.
Correct. You need to study for something else. Can you use this 1 hour to study for your exam?
Okay.
All right. Let's move this 1 hour to next week, or rather, maybe after the exam is over. That's the point, right? So that means after exam, you have 2 hours in 1 week. Make sense?
Yeah.
Okay. Shall we do that?
Okay.
Yeah. Special just for exam week. Okay.
Okay.
I'll see you. Does that mean that I'll see you next Sunday? Is next Sunday exam over?
Yeah, Sunday math, the exam over already.
Then I'll see you next Sunday. Okay?
Okay.
All right, see you. Bye-bye. Tell your dad, yeah? Why, yeah? Just tell him.
Yeah.
Okay, bye-bye.
Bye.
Bye-bye. Arya, how about the updates, right? Don't watch videos.
Yeah?
Your updates, please. I'm still waiting for your updates.
Oh, right. That one.
Right. Don't watch the videos. Bye-bye videos.
It's all right.
Bye-bye video. Yeah, there's a lot of work right there. But
Oh,
this- Okay. It's a lot of work. Why? Why not 2? Daniel, why not 2?
Hmm?
The 3 shouldn't be there. It's y, right? A line is y mx plus c, right?
Yeah.
So the 3 shouldn't be there, and the 2 also shouldn't be there. Yeah, nice. And then you simultaneous equation these two things, which you can use a calculator, right? Save you some time and brain power also. The chair is very small. Okay, Arya. Okay, I've seen your update. Wonderful. Why is your chair tiny? I'm so sorry. Arya, why is your chair tiny?
it isn't going up, so I can't see stuff.
Can you change into a more comfortable chair? It's okay. I'll wait.
Okay.
Right. Yeah. Get a nice chair for yourself.
How to do simultaneous on the calculator?
What calculator do you have?
The FX96SG.
Right. So you go to the mode, right? Mode 3, and then tell me what you see. Do you see that? I think mode 3.1. So mode 3.1. Yeah, mode 3.1. Correct. Right. And then do you know how to use it? Because you have to rearrange your equation a bit lah.
Yeah.
Right.
A is x squared. Right?
A is no. There's no x squared here. Ax plus by equals to c. Ax plus by equals to c. So I think it's mode 3.1. If you have no idea, let me help you. This is like super useful in exam, like super.
So
Ax plus by, right? So A is the guy in front of x. That means you have to reorganize. Look at the
Therefore, if you look at my equation, then A would be -1.
No, wrong. You have to wrong. You have to reorganize. So, check out Jamboard. Check out Jamboard. Still very useful to know. So we're spending time on this. So reorganizing into Ax plus by, right? We have to reorganize a little bit. Yeah, correct. The one you see is nice. Yeah. I have reorganized to Ax plus by equals to c lah. If that makes sense, the calculator demands this lah. Does it make sense to you? Does it make sense? So 114, right? Something like that.
Okay, that's -1/6.
And 1 and then good, Arya. Just this one type in, yeah, Arya. Yeah. Also, where is your video? Right? Yeah, let's see your video. Right. Give me video and don't mute, please. Yeah. All right, so I type something, Arya, please reply more, yeah.
Okay.
It's incorrect.
Yeah, there must be
1/7, 15.
Correct. There must be a characteristic now. This is just normal. Let me just find it. Okay, I just copy and paste, and you something else. That happens. That always happens. Because this is a lot of work. This is a lot of work. So something is bound to happen. All right. Let me check.
Give me a sec.
Question 4 start. Question 4. I'm focusing on question 4. Question 4 is what they call parametric. Parametric, I have never touched with you before. Have you heard anything about parametric before? Daniel? Daniel, have you done parametric before? Oh, you sent me something through WhatsApp. Sorry. Wait. Oh, the one before. Okay, I understand. Oh, yeah, sorry, Arya. Yeah, I didn't get it. Sorry. Thanks for reminding me. Now I get it. I understand. Okay, Arya. So, you remind me something, Arya. Yeah? Don't be muted. Yeah. So, I remember that last week we go through significant number. Significant number is not part of the exam, right? So, tell me again why last week you decide to talk about significant number and not the exam topics. Tell me again.
I'm pretty sure this is I forgot.
Are you ready for exam? Is that the reason? Basically,
No, like I forgot that significant numbers wasn't tested. It's because you see, wait,
Hello, I'm back.
Yes, Danny.
I'll bring
I found a mistake.
Right. Sorry, continue. Okay, Arya, sorry, you're saying?
I'm gonna go bring my textbook. I want to show you something.
Sure, please do. You found your mistake, Daniel? Is that what you're saying?
No. Unfortunately, I will take a look.
No, don't. Okay. I will find. You're supposed to find it, but we are running short of time. 4. Question 4 is parametric. Look at question 4. Does that look familiar to you?
It looks scary.
Yeah.
There
is no other
stars.
parametric. There are no parametric somewhere. So I'm going to ask you to ignore parametric for now. I'm uncertain where your parametric is supposed to go. So rather than doing that, let's do the more obvious one. 5, 6, 7, 8 is the more obvious questions anyway, right? So do 7.
Can I skip to 7? Yeah.
Yes, no problem.
Skip to 7.
7 or 8 or both.
Okay.
Up to you. Okay, do that first.
You just do all the star ones. They probably star for a reason, right?
Let's try. Let's try.
Okay.
We are short of time.
Is it okay if I stay until 8:10, or would you like to cut short?
Try 7 first. Try 7 first. We'll go one by one. They are all significant questions, so we don't decide lightly what to skip on. We just go one by one. I've reviewed your 5 and 6. That's why I say, okay, let's go to 7. Okay, that's fine.
Yeah, so significant numbers are used in chapter 3, right? Approximation and estimation.
So it's part of exam lah.
No, wait, one second.
Yeah, just make sure. Just make sure.
Yeah, it isn't. It isn't.
Okay.
Approximation and estimation is not an exam.
Understood.
That's why I was confused because chapter 3 I thought was an exam.
Right. So last week we weren't discussing the writing lah, basically lah. The second, yeah. Okay, understand. So this Tuesday is the exam lah, right?
But no, wait, I need to check one again.
Yes, please check until you're sure. Yeah, 7-star probably shouldn't be a star. Just making sure that you can do it.
Yeah, it's
not that complicated. Yes.
On Tuesday.
So what's going on here?
Wait, it's not 0. It's 14. Okay.
Very good. Nice. Daniel. Good. What else can we do? What else can we do?
Wait, no, that's too bad. So, let's see. Find the values of A and B since Y.
Oh, goodness me, I found a mistake.
How bad is it?
I think careless mistake. So whether that's good or bad, I don't know, but it is at least not conceptual. That's a start. Later. Just finish your 7-star. 7-star is not supposed to be very difficult. So this is again a test of your concept. It's probably not a star, but let's see how you do.
Wait, I'm brain lagging. So if it means y equals 16x minus 9, it's tangent to the curve.
Let me repeat.
That means it is the gradient.
It is a tangent line. Be careful, it's a line, right?
And
you want to find the gradient I like. That's aligned.
So therefore, gradient is 16.
Very good. So therefore,
right.
Very good. Good. That's the concept. That's
cool.
Arif, are you back? Just check.
Yeah. Hello.
Yeah. How is it, Arif? What do you want to check? What do you find?
So my exam is on Tuesday.
Right. Nice. So what did you want to check this?
I didn't want to check anything. Wait, I'm confused.
Yeah, sorry. Just now you say that you want to check something. That's why I was waiting for you.
I want to check what date it was. I wasn't sure because the post I sent you was from another class.
Right. Okay.
But the topics the topics are the same.
Good. So now you're certain about your topics and your day of exam, right?
Yeah.
Okay. This will happen definitely before the next tuition.
Yeah.
Right. So there isn't much that we can do for the purpose of exam, but I still want to know. What do you think about your preparation for the exam? What do you think?
I'd say it's pretty good. Like the last mock exam, I got 11 out of 12.
11 out of 12 is excellent, my friend.
Yeah.
No.
So I wouldn't say it's bad, but it could be improved.
Right. Please estimate what you will get. 30 marks, right? 30 marks. So
I'm pretty sure it's out of 30.
So you estimate how many marks you will get.
18.
All right.
That's
so
don't make any silly mistakes.
Oh, no. Whenever you estimate including the mistakes you may make. That's not an estimation just now. The estimation must include, based on my experience, I might do certain silly mistakes. That happens, right? That we are human beings, and you haven't learned how to handle them also. So it's likely to happen again. Revise your estimate, please.
I'd say 15.
All right. So you're saying that 18 minus 3 lah, something like that, right?
Wow.
15 over 30. Right. So in this, I guess, 45 minutes. Okay. In this less than 45 minutes, which topic would you like me to help you make stronger? We can only probably do 1 or 2 laps.
Rational numbers.
All right. Now, I'm not certain what is your problem with rational number. If you could tell me, or if you could show me a question, even better.
No, I'll just like show in the Jamboard what I
yes, please,
think
please.
are rational numbers, because like me and my dad spent like about 1 hour just revising.
Oh,
okay.
Show me.
So pi is an irrational number.
I'm sorry. Are you writing something? Sorry. If you're writing something, use paper, please. Like your video is off. Let me. Please on your video. Please on your video. I'll write on the Jamboard lah.
Oh, wait. One.
So pi is irrational, not rational. Okay, you got a B. Okay, good. And then you have A. So in your Jamboard area, look at page 3, right? I'll follow you in your video.
Yes, correct.
Good, wonderful. So your logic is, maybe you can do another half question. You can skip 8 if you want to.
Okay. Can I see the rough for question 3? If that's okay.
I cannot tell you where the mistake is, okay? You have to learn how to find it. Okay, I'll give you a very slight hint. It happens kind of early, and I think it's careless. I think.
Okay then.
Oh, I might be mistaken. Wait, I'm sorry, I might be mistaken. I don't think that's your mistake. I'm so sorry. I think I see wrong. Okay. Aryav, adjust your camera so that you don't look slanted. No, instead of adjusting your paper, you adjust the camera. Okay, good. Sorry, Daniel. I revised my statement. I haven't seen your mistake. I see it wrong.
Like something like.
Okay. Again, adjust your camera, not your paper. Adjust your camera, please.
Wait, one second. I'm not looking at my camera. But,
yeah. Try to look at it. Then you know how to adjust.
Yeah. Okay.
So I did write something on the Jamboard. Yeah. You're adjusting your paper again. Don't adjust your paper. You always go back to slanted one because you're right. You write comfortably there. Don't adjust your paper. Adjust your camera.
Oh yeah.
What you wrote is correct lah.
Yeah.
What's your question? What is your question?
I was clarifying.
Right. Okay. What you wrote is correct.
Okay. Thank you. Okay. Yeah, it's because I was being confused by. I was being confused by like which one is rational and which one is irrational.
All right. Daniel, in this case, I'll see you on Tuesday. Would that be okay?
Yeah.
I will strongly suggest that you do 5.2 only. I think that's the better route if you're running out of time. That is still my assessment in 5.2. I think that's the most important one. 5.1, Whatever, like if you have time. If you're short of time, that's my suggestion. Okay, so on Tuesday, maybe you can ask some questions and then continue. If that makes sense. Right. In the meantime, I'll go find your mistake also after deletion. That be okay?
Yep.
All right. I'll see you on Tuesday then.
Okay.
All right. Bye-bye.
Uh-huh.
Okay. So Arif, let me test you a few. Look at the Jamboard, okay?
Okay.
Rational or irrational?
Rational.
Right. Now, here's a good news for you, okay? Any form of fraction is rational.
Yeah.
So if you see a fraction, it's not irrational. Now, let's put the name irrational. Let's put the name irrational to a more common understanding, because irrational means crazy, right? That's what irrational. Rational means not crazy. Okay, that's not what it actually means, because the math guys tries to use the word in a non-natural way. It's not natural for us to call 21/10 rational and pi irrational, right? Because pi doesn't mean crazy. Irrational simply means it's not predictable in any way or form. Not predictable.
Okay.
Whereas, if therefore rational means predictable, if that makes sense, rational means predictable. 21/10 does look and feel predictable.
Yeah.
So that's what rational and irrational kind of means. It helps us think that way. Don't think rational and irrational. It's a very weird word to describe. Better use in our mind, predictable or not predictable. Do you understand what I'm saying?
Yeah.
But of course, in exam, you still have to use the word rational, irrational. But the meaning is predictable or not predictable. Now,
Okay.
1.41, predictable or not?
Predictable, yes.
So you say rational in exam, makes sense?
Yeah.
22/7, predictable or not?
Yes.
Even though it's never ending, correct? It's never ending, right?
Wait, it is?
Oh, you try pressing your calculator. Show me your calculator. 22/7 is never ending one. Show me your calculator.
Oh, I get it. Wait. Yeah.
Right, show me. Yeah, but why do I claim that this is predictable?
Because it can be put into a fraction.
True, that's one. Secondly, the decimal is repeatable.
Huh?
Show me your calculator, right? That's why. Show me your calculator. Okay, your calculator doesn't show. Okay, because the 3 behind is supposed to be 2/8, right? So I'm going to show you something from Google, for example. Let me just show you. Okay, so just a minute. I'm going to type something. Then I'm just going to type. Right. So the Google gives us a slightly more accurate one for 22/7. Okay, look at the Jamboard.
Okay.
I claim to you that it is repeating. I claim to you. So see, 1 and 1. See, 4 and 4, right?
Oh, yeah.
2 and 2. 8 and 8. And then this 6 is actually 5. 5 and 7.
Yeah, but they're on the dot.
Yeah, I'm sorry. Yeah, correct. No. So your calculator is also doing that. It's actually not 3, but 2/8. 2/857.
Yeah.
So this means that it never ends, but it is repeating. Therefore, decimal or fraction, it is predictable. Do you understand what I'm saying?
Yes.
But pi is never repeating. So therefore, not predictable. Try your calculator √2, please. I'm trying to say to you that in exam, you can test this kind of thing. Let's try √2. Does it look repeating?
Oh, √2.
√2, not pi. Pi also not repeating one. Try √2. Does it look repeating?
No.
Therefore, that's it, irrational.
Oh.
This is not the easiest, this is not the most foolproof way, but it's 99% correct one. Using calculator will help you see predictable or not, something like that.
Okay. Thank you.
Okay, right. So let me ask you lah. Let me ask you again. Well, come on.
I didn't see that. 21, 22. Yeah, it's rational because it's a
Yeah.
fraction.
Because fraction, simple, right? Why? Because fraction is predictable, right? Right. So here's another value from your calculator. There's a value E actually. Do you see the value E in your calculator?
Yes.
Right.
Wait, is it the
Show me the calculator. Show me the calculator in video.
this E or this E?
Yeah, the small e. Small. So
Oh.
just use the small e and then press equal. Okay. So the question is it predictable or not? Is it repeating or not? I guess that's the question.
It's unpredictable.
Man, your calculator is tricky, man. Your calculator gives the impression that it's predictable. The 1828128, right?
Yeah.
But after that, it's not repeating. After that, oh, your calculator, oh, a little bit dangerous, right? But it's not repeating. Yeah, it's not. It's not. It looks repeating. It's not at all. Actually.
Yeah. I mean, I said it's not because it's a 7 at the front, and then 1828, 1828, which
Right,
means there's not another 7 when there's meant to be a 7. So it's not repeating.
So it's irrational, something like that, right? So this should cover around, sorry, not 90% of the things that you encounter in exam. Helps you a bit, huh? Helps you a bit.
Yeah.
Okay. Right. What topic do you want to discuss to be strengthened?
I'm okay with most of the topics.
Let me test you then.
Yeah, okay, thank you.
Page 4.
Page 4.
Now we're talking about prime, HCF, and LCM, right? The techniques that you learn from class is probably okay if the questions are not very difficult. So let me give you an example. 120 and 45, right? Then they ask you for the HCF and LCM. So far so good.
I can't hear you.
Arif, you cannot hear me? Sorry. You cannot. Right, page 4. Right, page 4. Page 4, yeah. 120 and 45. Correct? So, and then HCF, LCM. So this is not a very difficult question. Your school method may suffice. So let me just see how you do it very quickly. Right. If you use calculator, then use calculator. If you don't, then don't. But use it. But do your best. Let me see on paper. Okay, I cannot follow you because again the paper is too downward. So adjust your camera. Push your camera down instead of push your paper up. Right, so that your camera adjusts to it. Okay. Can you push more? Can you push more? More. Camera down even more. Cannot? Can you?
It can't for the circle. Yeah.
All right, let's try then because I can only look. Okay, never mind, let's try again.
Is this okay?
Look at the video. Okay, now I think it's more downward, but the paper must okay. Yeah, see? Okay. All right. Yeah, just try. Okay, I understand that's your teacher's method. That's fine. It's fine. For now, it's really fine. The mental calculation seems okay. Okay, now what do you do with this? Right?
And then I write 2 cubed times 3 times 5, and then I write 3 cubed times 3 squared times 5.
Okay, unfortunately, you have to pull your paper out. I just cannot see it. Pull the paper. I just cannot see it.
Does this work?
Okay, you're very slow. Are you using a wired connection?
Yeah.
All right. Okay. Just now, connection problem. Very bad connection problem. Okay. Yeah, it's the same problem. Just look at your video. I cannot look at the bottom part. Yeah, look at the video. Is it not possible for paper to simply move up, right?
It's not. It's because you see it's like this, right?
Okay, your video is lagging.
Like for me to do it. Move it to the front. Let's see, there's no more space.
Your video is lagging though. Yeah, okay. Don't use the bottom part of the paper lah. And just use the top part lah.
Okay.
Okay, now rewrite the 2 cube thingy. Yeah. Okay, looking good. Then the other one. Okay, that's how you write. Then how about the HCF and how about the LCF?
Then I write it'll be 3 times 5, which is 15. So 15 is the HCF. And then for LCM, I'll do 120, 45. 3 become 40. Oh, I can't hear you if you're talking.
No. The HCF is
HCF is
right. Then your the LCM you repeat. You repeat. Oh wow. Okay, that's a bit weird. Let me see you do it. Okay, let me see how you do the LCM. You're gonna repeat. Okay. Oh.
Sorry. Yeah. So it will become 3 times 5 times 8 times 3, which is 360. 360 is
the
the
360. I kind of agree. Oh, actually, I agree. Now, here's a wait, what? Oh yeah, I agree. Of course. Now, let me show you. Seems like you're quite fast. So I'm just going to show you an alternative method. At this point, you shouldn't choose the speediest method. You should always choose the method that you're most comfortable.
Yeah.
Right? But in case I show you a speedier method, you're also comfortable, then you probably want to switch just before exam. Remember, this is 2 days before exam. You shouldn't switch just for speed reason. You should follow your method which you're comfortable until after exam, then we make changes. Okay. Unless the new method you really like. I'm going to show you. Right? So rewriting what you do, however, I write down in a slightly different form. Notice the difference of the way I write. Okay? Now, your HCF, you immediately is 3 times 5, isn't it? Right? No explanation needed, right? So, yeah. The LCM, the logic is very simple. It's called multiple for a reason, right? So multiple means go for the biggest guy, though. Right? That's not the best explanation I can give you. That's just the fastest. So you see nobody here, right? Yeah. Nobody here. Doesn't matter for LCM. You just go for the biggest guy in every row. The biggest guy is 2 root 3, correct? 2 power 3. Who's the biggest guy in the row 3?
3 square.
And who's the biggest guy in row 5?
Just 5.
Press your calculator.
Oh, wow.
360 also, which already tells me that your other method is correct. Right? Now I'm comfortable with your old method because you at least look fast with it, at least, you know. But this new method is not just faster, it is less step. Less step means less mistake in exam. If you understand it. If you understand it. If you don't understand it, you're forbidden to take this new step until after exam. What's your decision?
I'll stick with my old method.
All right, for now, yeah, I'm okay. Yeah. Now, here's the real test for your old one. What happens when the number is big? That's the problem. Okay, so this is a new school for you, right? You've just entered this school for less than 2 months, right? And this is your first kind of semi-major exam, kind of like maybe I'll get maybe a bit serious, 45 minutes, right? So I have a question that I'm very curious about. Right? Will your school give you suddenly more difficult question in such exam? Up difficulty compared to your normal practice lah. Can you hear me? Can you hear me? Arya, yeah, your connection is very bad, Arya. Hello.
Okay.
Right, connection is very bad. Can you hear me? Arya, instead of talking, I decided to type lah. Connection very bad.
Okay, I'm back.
Okay. So testing your technique with a harder number. Please try.
Testing my oh wow.
This is in case your school is that type of school lah. He whack you with something like this. We'll find out tomorrow lah. Tuesday lah. Does your school whack you like this? Just half of the page, okay? Okay.
Wait. What are we doing again?
Same thing. The question is always HCF LCM.
Okay.
Right. So what will you do here?
Right. 2 squared times 3 squared times 5 squared.
The HCF is 300. Okay.
This is for HCF. Not for LCM.
CM now. Here's the trouble. The trouble is usually at LCM.
Yeah.
What will you do? Right.
I mean, actually, it kind of goes on like this. Same. Okay. Can you see?
Since the 100, I cannot see it.
Since
Correct. So your answer is what? Okay. I mean, I understand that this is your LCM method. The bigger the number, the harder it gets, basically. But so your conclusion is your LCM is 18,000. Yeah. Okay. Now let me show you a way to test your answer in exam, whether easy or difficult number, right? So this is at least what I want you to learn tomorrow. How to test whether your answer is correct or not. Let me show you something. Yeah. Hopefully you can understand this. Now this is 1,200 and 4,500. I'm going to put 300 here. Okay. I'm going to put 18,000. Okay.
Okay.
You notice that this is times 4, right?
Yeah.
And you notice that this is times 15, right?
Yeah.
Now, check out. This is times what, and this is times what. Check it out. You can just use your calculator.
No, sorry. 15 and 4, 5, 6. 4. Yeah.
Good. Now, you notice that this is the same, and the other one is also the same.
Oh.
This is very likely to be correct. Very likely. It's a good news. Let me show you using the previous answer. The previous answer was 120 and 45, correct?
Yeah.
What is your HCF?
Wait.
3 times 5. 3 times 5, which is?
My HCF was 3
times 5.
Yeah, 15.
And then the LCM?
LCM is 360.
Okay. I don't explain why this method works, but I want you to test your previous answer with this method. See whether you're right or wrong. You test yourself.
Okay. Eight. 3.
Yep, that's 8 and 3. So how about the other side?
This is 3.
That's good. That's already a good sign.
8. Yeah, so it's correct.
Right. Okay. I don't explain why this works, but this works well. So in exam, if you test this very quick to test, right? If there is something wrong, you can sense immediately. Currently, you're correct. Okay.
Yeah.
Any questions so far?
No more questions.
So I don't like your method because it's slower, and yet it is correct for you, and you're actually quite speedy with it. So actually, my complaint is almost nothing for now. Hopefully happy, right?
Yeah.
Do you need to improve? Maybe after exam. For exam, this one, the basic technique seems okay. No?
Yeah,
However, HCF and LCM always continue on to the second and third part, which is harder.
Yeah.
They ask things like, to make it perfect square, to make it perfect cube, to make it divisible by this. Have you experienced those kind of questions?
Yeah.
Right.
Yes.
Then I'll give you one question immediately in page 5. Right?
Okay.
Okay. I'm going to use the previous number. I say 120. Yeah. Say 120. You say it's 2 to the power of 3 times 3 times 5, which is correct. You're correct there. Okay. Right now, he asks you something like this, very common. 120m, okay, is perfect square. What is the smallest m? It's a very common question.
120m is perfect square. It would be 2 times 3 times 5.
Excellent. You are correct. That means you understand, is it?
Yeah, I know.
So how about perfect cube?
Then it would be 3 squared times 5 squared.
Wonderful. Wonderful. I'll give you something harder.
Yeah, like you'll put m and then you'll put q here, right?
No, I'll just put over it. I just put over m. That's enough.
Oh.
If you can do this, I'm already quite happy. Oh, sorry. I supposed to get it. Right, so 120 divided by m, and is what? So that's always the question. Is what? Perfect square. In this case, what will be the biggest m? Right? Doesn't matter. So what do you think the biggest? Right? What do you think m will be?
Perfect square because m.
Divided by m.
Damn.
Because time is short, yeah. I'll give you a hint.
For this one, I don't know, but for like 120 q over m, no.
No, well, it's more complicated, right?
Yeah.
And are you sure you can answer q over m? I mean, it's already like.
No, like I forgot this one.
Never mind, just the over m is enough, right? So let me explain. Because you understand the 120 times m, that's already a very good start, right? Very, very good start. So let me explain the over m. Now, times m means you just add on the power, right? Correct? Oh, I need this to be power 4. Right? You get the correct idea. Divide by m means I can only remove power, right? So I hope it makes sense to you that 120 over m.
Wait, what if I were to remove 2 times 3 times 5?
Correct. You're correct, no? You're correct. Yeah, that's it. You're correct. You are correct.
Oh. Oh wow, yay.
That's the logic. I hope that makes sense, right?
Yeah, so you just remove.
Yeah.
So like for this one where you times it, wait, my bad. For this one where you times it, you have to add more. But when you division, you have to remove it.
That's all. That's all. Yeah, you can remove 3 and 5. Nobody say you cannot, right?
Yeah.
Right. Okay. So that's it. That's it. Okay. Hopefully the exam doesn't go more complicated than that.
Yeah. Okay. Thank you.
Hopefully. Right. No problem. So maybe we discuss. There's still 5 more minutes. So you're saying that you don't have particular problem, right? Okay.
Yeah.
Think through. I'm okay with that. Okay, I'll show you an exam question. I'll show you an exam question from end of year, right? End of year, right? Get it? Yes. Okay, give you some simple stuff to try. Page 6, please. Yeah.
Okay. Express 0.085 as a fraction in its simplest form. That would be like 0.085, 10, 100, 1,000, 1,000. So we just divide by 5. Yeah, okay, so this is for A. B, 4% as a decimal. 4 by 100. An ascending order. 7 to smallest to biggest. Oh wait, they're all negative, right? 3, 8. 37. Okay, so first is 0.37, then followed by smallest to biggest, then followed by 0.37. Then followed by 16. What is this? Four percent as a decimal is 4/100, right? Oh wait, eight, my bad. 0.04.
Yeah, cool.
Yeah, 0.04.
Right. So the ordering, please. Sorry, have you finished or you finished or sorry. Move up. What's your minus 16 over 42? So ascending. Wait, this is a minus number.
Yeah.
Ascending means that means you're wrong lah.
Yeah, it's opposite. From it starts.
Be careful. Be very careful there. Okay.
Yeah, it's negative number, right? Right. I forget.
Yeah. All right. Then the estimate, please.
Estimation is not an example or whatever.
Oh, it's not. No. That's not which time. No, sorry. I thought it is. 5A, please. 5A, they phrase it slightly harder. So
Expressed as the product of its prime factors.
that's normal. That's not normal.
Oh, okay. Yeah, right. It's normal. 675. So it said 675M is a whole number.
Okay, so this is the phrasing that just in case your school say it, you like, right? Next.
I mean, it's still really easy. It is still just 3 for 5B.
Very good. You are correct. So you understand. Very good. How about C?
It would be 5.
Very good. You understand. That's fine.
Yes.
Okay. Right. No need to overcomplicate things before exam. Curious what will happen? Tell me what happens now on when we meet on Tuesday.
Okay.
All right. Good job, Arif. I'll see you on Tuesday. Bye-bye.
On Tuesday. Okay, bye-bye.
Yes, Kakak Brian, I can see you.
Yeah.
All right. Elliot, today, chemistry tomorrow. So Elliot requests tuition on Tuesday more lah. So that's what I'm gonna do.
Okay.
Yeah, exam week, exam week. So you go. Yes, Kyoko, can you hear us?
Hmm.
All right, I can hear you also. Very quick new Jamboard, Kyoko, quick update, and then you can practice questions.
Okay.
Kakak Brian is with Kyoko today. Yeah.
Yeah.
Oh, Anish, I can see you. Can you hear? Kyoko.
Hello.
Yes, Anish, I can hear you. I understand, Kyoko. I've read it. I replied a short one. Anish, can you hear me?
Yeah.
Speaking. Kyoko,
shared-
looks like you must be out. Yes, Anish?
I've shared it already.
Oh, right. Okay. Okay. Kyoko in out, yeah, so you can see my. Yeah. Okay. I understand, Kyoko. So just checking, yeah. We might, okay, on schedule, we'll just meet on Wednesday. At that point, math exam is done, right, Kyoko?
Hmm.
So you decide if you are sick, then we'll just do that, okay? You need to rest, right? Exam, you need your best possible self, right? Sometimes you usually make up on Monday, which is tomorrow. I just leave it to you. You want to come tomorrow? That's good. You cannot come tomorrow? that's also fine. It's okay.
Okay.
Okay, Kyoko. So for today, I wish you a good rest. Yeah?
Okay, thank you.
Okay, yes. And that's the decision, Kakak, right?
Oh, then like, do I stay or?
There'll be Aditya. So
Oh, okay.
there'll be Aditya,
Okay.
right? So,
Sure, sure.
yeah, and Aditya would have finished exam, so not so much of a thing. Okay, you can do fix. Okay, your decision, Inesh, is to do physics and math today. That's fine. Understand. Understand. I understand, Inesh. Right. If there's nothing else, right. So, shall I wait for your physics question? Physics
Yes.
and math, just dump it, man. We'll answer as many as we can. All right.
Okay, it's a whole paper out of 30 marks, 10 MCQ and 10 short answer. The 5 short answer. I could share this to you, I guess. Or should I just take pictures of every question and put it in a example? Hello?
I'm so sorry. I was muted. So sorry. You want to take pictures? Just take pictures of everything you want to ask today, lah. Right? Easier that way, lah. Put it in first. All right. I'm looking at the questions. Anesh, are you still putting in questions?
I can put in more. I thought we just do this.
Yeah, put in more first, lah. Put in more. Just put. Yeah, we start. Okay, Anish, I'm already starting to give you hints from the first page. Then once you put in your question, just go to the first page and start doing it.
Yeah.
Here I can see your video. Yeah. Okay. Anish, are you doing? Yep. Are you doing page 3 already, Anish? Anish, will you have video? All right. I'm seeing your video, Aditya. Yeah. Seeing your.
Yeah.
Okay, Anish, are you starting, Anish? Anish, do you have the Jamboard, Aditya?
Doing it.
All right. Anesh, are we starting, Anesh? Anesh,
Yeah.
are we starting?
Yeah.
What do you mean by yes?
I'm starting. I'm reading the questions and the hints.
All right. Right, you have decided on the formula, Anesh. You can see that, right? Any Jamboard, Aditya?
Oh yeah, I didn't share. I just started typing.
Anesh, write your formula properly, please. Your English is great. Your letters are not.
Oh.
Can you zoom in a little bit, please? Thank you. So the answer will be which one, Anesh?
D.
Sorry, yeah. Zoom out, please. I cannot see the D, but you're correct. Zoom out a little bit. Thank you, Dan.
But you putting a tick doesn't mean it's correct. Oh.
No, tick means correct. Tick means correct. Oh, there you go. Yeah. Okay. Now, okay. Oh, wow. Share kakak. Kakak Brian, share. Aditya, just to confirm, you're still typing, yeah?
Yeah.
Understand. Wow, okay. I didn't know that house prefect can punish people.
I mean, he was in charge of assigning people for like we have a shortage of guys. Like we have more girls than guys in our year level. Like for my house, like there's 12 girls and 8 guys.
Right.
So we had a shortage of people who signed up for sports day because we're not really like 2 of those guys don't play sports. I
it's
just
not
don't like athletics.
punishment. Oh,
Yeah.
you're just
He
assigned
did it
a
to get
sport.
revenge.
I
No,
see,
but
I
like he specifically assigned me to get revenge.
Right. Perform as well
because
as
I
you
made
can.
fun of him.
Well, I mean, perform as well as you can, no? Maybe that's a good way to get back.
Yeah, I need to go to the gym. I haven't gone to the gym in a long time. Like I've gone for basketball training, but they
This
like
is
don't do
this is a sprint,
endurance
right?
anymore.
This is sprint, right? Relay sprint, right?
Yeah.
I don't think gym is gonna help you. If you want to sprint, you
No, I mean
practice
I'll go on the treadmill. Sorry?
Treadmills don't help you sprint.
Oh yeah, because they can like carry your feet for you. Yeah.
Yeah, as in you don't want to run very fast on the treadmill. That's treadmill is for endurance, cardio. You want to practice sprint, you
Yeah.
practice on real track.
Okay.
At least that's what I think. Right?
Can go to Clementi Stadium.
Right. Still typing.
Yeah.
Okay. Right. Right. So far, so good, Anish, but nothing complicated. So a good warm up. Good. Right. Good.
Question 4 is trying to trick me, right? Or am I missing something?
Sorry, no, you're correct.
Question 4 is trying to trick me, right?
I'm sorry. Which question? Sorry.
Question 4.
Question 4 is a trick question. No. Question 4 is a kind of standard question.
I know, I'm just very weak in physics. I just want to make sure I'm not missing it. Like 0.5 is not needed.
The 0.5 meter deep is not needed. Actually, right. I guess you are asking the right question. Now, can I not give you the answer?
Yeah.
The only thing I can say is you are asking the right question.
Okay.
So I can tell that you're thinking on the right direction. But I will stop short of confirming whether you're correct. Aditya still type yes. Good, Ines, so far so good. Aditya, can you go in and out so that no error will wipe out your typing? Then I can also read forward. Then you can continue going in and type. Just go in out of the text and go in the text. Okay, nice. Yes.
Are these exam level questions?
A bit easy lah, especially question 1 and 2 lah. Bit easy. So starting 4, it starts to be more. I guess 4. Okay lah. Right? I guess 4. So that's why I say it's just a warm up.
That makes sense.
The P and C, right? Okay, I understand. Okay. So Ines, paper up, please. Question 5, what do you think?
Yeah, I'm thinking.
Relevant formula, please. relevant formula? What do you think is the relevant formula?
E equals to H.
Let me see it written down. Confirming, Aditya, still?
Yeah.
Okay. Do type when you have confirmed. So there's that. Okay.
Oh no,
Anesh,
we're doing a arithmetic progression. I'll just type it down.
Okay. Right. We can get ahead, right? As in we can discuss your textbook. Okay.
Yeah.
All right. Let's do so. Right. Kakak Brian will be helping. Okay. In this case, we go in a learning mode, slow mode. Take pictures and then we'll discuss your text. Anesh, I agree with your
I mean,
relevant
it's
formula.
just. I think it's just the same thing that we did in emath, right?
Then go to the questions, then see whether you're correct or not.
Okay.
In case, so that we're not surprised.
Does the base area matter?
Anesh, I'm going to test you, Anesh. You're ignoring the base area.
Yeah.
I mean, is it a yes or a no or don't know or what?
I don't know, but from what I know, I'm ignoring it. But it doesn't make sense to ignore.
So what? It doesn't make sense to ignore or it doesn't make sense to include? Huh? Which one?
It doesn't make sense to ignore it, but from what I know, I should be ignoring. So I'm kind of confused.
You are, but decide lah. You are. Then we
I'm
discuss.
gonna ignore it for now and see my results and then decide.
Okay.
Mr. Philip?
Yes.
I was actually thinking that like since differentiation is after this, my teacher said that it's gonna be like all the past topics coming back to haunt me.
Yep. Correct.
So
Slowly lah.
Is it okay if we like start differentiation? Because
of course. It's a super big
like
thing.
I want to be prepared before
Okay.
I die.
No. You die a little. Okay, so you didn't join the holiday tuition that much, right? For differentiation. Let me confirm.
Not at all.
Okay, Kakak Brian. Can you hear me?
Yeah.
I think we have to switch. Can you help with physics instead for Aditya? I think we have to switch. Would that be okay? Pressure.
I can try my best.
You check it out first.
Yeah. It's very like just F equals P and rho GH, right?
Yeah, I think that is still the level. The application is the one they're trying to trick you lah.
Yeah.
Okay. Right, so you check it out for a while. If you don't say anything, then we'll switch. Okay.
I'm gonna do more topics though. In physics, there's like pressure, energy.
Yeah, pressure, energy again should be okay. Yeah. Kakak Brian is a H2 physics. Probably gonna be very okay.
No problem.
You will have to explain a lot probably, Kakak Brian, at the later one. So if you really want to, just tell me lah. We go break up.
Okay.
Aditya, so we'll try to start with differentiation. Differentiation is sorry.
Can you share me really? No.
I have just done that. Can you see? So I'll take off the sharing from Aditya. Yeah. Okay, Aditya, I'm gonna say the only understanding for differentiation that you need, but you have to remember this.
Okay.
Are you in page 2?
Yeah.
My question 5 correct.
Right? Yeah, okay. Page 4.
Yeah, I'm looking at the question.
For question 4, I'll just answer first. You're correct. You're correct, Eilish. And you're
So I was
correct
right to skip it.
you're
Like, I was right
correct
to
to ignore. Yes. You're correct to ignore. The base area doesn't matter for liquid.
But logically, is it not the
Because
they
of the
didn't say-
formula. It's because of the formula you're using. The question 4 formula, of course, the area matters. The question 5 formula, which you start properly, the area doesn't matter. That's the shortest explanation I can give you. Certain formula already takes into account the area. That's why the area seems to not matter. So it's only because of the formula that it seems to not matter. And you are correct to choose the formula, so it does not seem to matter. That's not the most complete explanation. But yeah. Okay.
Yeah.
I mean, that's what we can do on your exam. But
Yeah. I don't know what it's.
okay, Aditya, I've written something you may or may not understand, but I'm going to start with this. Yeah, Aditya, so far so good?
I guess, yeah.
Now, let me show you something. This is now almost like a memorization. Almost, yeah?
Okay.
Now, I'm going to do a lot of okay, and I need you to respond okay or not. Okay? Even by a mouse click, that will be fine.
Okay.
Okay, now answer okay or no okay. Okay, now you just okay at the side of the okay, so I know which okay you're doing. Now,
I don't know how to do a question.
and because this is exam, Brian, I think I just shift to the breakout room. Okay, I just shift. Okay.
Wait, can you go through with him this one first? Because
question 6.
Yeah.
Question 6.
Yeah, then I'll write the
Finish. Relevant formula.
From what I know, the relevant formula is atmospheric pressure is 100,000 pascals.
I was surprisingly, I was expecting you to say the same thing. I'm a bit surprised that you don't. Okay, so right.
Okay.
Well, so never mind. I'll start this way. Sorry, yeah. Be occupied for just a while.
Okay.
Okay, next, right?
So isn't barometer like the atmospheric pressure works on the mercury over here, and then it just
this
pushes
one
it up?
is correct. Okay, yeah. So this is atmospheric pressure, okay? So now if he wants 4/5H, right, then rho G also, right? Then it is obvious to me that this guy will be, well, 4/5 times 100 kPa, lah, if that makes sense to you.
Oh, okay, yeah, that does make sense.
So the pressure lessens as you go up anyway, right? Because you have less liquid on top of you. So it does lessen. It wouldn't increase, lah. That makes sense also.
Yeah.
Okay. Right. Now, this is totally assuming that this is vacuum. He doesn't say anything, you know. So I guess that's an assumption. When that's not vacuum, things change.
Yeah, because the air exerts its own pressure.
But we are assuming that. So just a little bit uncomfortable with it.
Yeah.
Would that be okay, Kakak Brian?
Yeah.
If you want to communicate with me, I'll be monitoring the WhatsApp. Okay, very good.
Yeah.
Tell me your concern. Okay, just tell me. Right? Okay, how we all right, please join in the room, guys. Okay, Aditya. Okay. Sorry, yeah. So this is the
No problem.
This is the formal notation. So whenever I write this is a formal notation of differentiation. You still don't know what that is, okay? You still don't know what's differentiation. I just tell you the function of differentiation. Okay, meaning it will replace the EMAF gradient y2 minus y1 over x2 minus x1, right? Right, so when I say dy dx, no explanation given, or y prime, no explanation given, that means I am differentiating the y, the sine x. Ainesh and Kakak Brian should be joining the breakout room. Ainesh, have you joined both to the breakout room? You cannot hear, I cannot hear you, but you should be able to. Your video is still here. So whatever differentiation means, Aditya, that means I am trying to find the differentiation so that I can predict the gradient. So now, also with, oh my goodness, also without explanation, the differentiation of sine x is, very strangely speaking, cosine x. Right? Okay. Again, there is no explanation given so far. Can you follow?
Yeah.
Right. So Aditya, are you okay? Are you concentrating?
Yeah.
Right. Now I'm going to share my screen. I'm going to see. Okay. Do you see Desmos?
Yeah.
Right. So, there. After this, I'm going to ask you to open your own Desmos. Okay. This is fine. Okay. Now this should come to no surprise that cosine x looks like this and sine x looks like that. So far, so good.
Yeah.
Right. Now, please pick a random point for sine x. Right.
Like,
tell me x equals to something lah. Pick for me.
Oh, x equals to 2.5.
Okay, 2.5. Now I did that, and then this point appears in the sine x. I can make the cosine x disappear for. Okay, so they can focus on it. Look at it, right? So the point here is 2.5, 0.598. Just a very ugly number. Right? Your video is gone. Are you okay?
Yeah. Phone is charging. It's like
right. Okay. So you're gonna annotate instead. So please annotate something on my screen. Okay. Come on, please.
Okay.
Right. So annotate something, please. Can you do that? Okay, good. Now draw a nice tangent line on that point. That doesn't look like a tangent line at all. A tangent line. A tangent line is a line that glances, right? That barely touches, right? Barely touches that point. It's a line though.
Wait, what? Like,
Could draw something, see whether it makes sense to you. Okay. I have drawn a line across that point, correct?
oh, you meant like that? I thought you meant like a tangent
No,
graph
no,
line.
no, I don't mean I don't mean a tangent. I mean a tangent line. So what is a tangent line? No. So actually, when I draw this line, I intend to ask you, did I draw a tangent line? I don't mean you should draw a tangent graph. Do you know what a tangent line is? And does this look like a tangent line to you?
Yeah. I mean, yeah.
Oh, okay, no. The answer is no. This is not a tangent line because this line doesn't glance the curve.
Oh, it passes through it.
Yes, it cuts. So the technical term for it is cuts through. But you're right. Normal people will say just it passes through. And a tangent line don't pass through. It glances. It is a very nice way to simply touch. No cutting, no crossing. So this is not a tangent line. So far so good. Here, yeah.
Yeah.
Now try this line. Does this line glances the curve on that point?
Yeah. Yes. No.
No. It's not. Definitely look at
Too
the
far
line
away.
is not touching on that point. So that one is clear. So this is also not the tangent line on the. Okay, let's try again. There you go.
Yeah.
This line glances the curve on that exact point. I must admit that it cuts through the curve at the next point because line is infinite. I must admit. We're going to pretend and ignore this. We're really going to ignore that guy. Okay. On that particular point, the line glances. So it's a tangent line. Okay. Now, use your EMATH method, right? Use your EMATH method and measure the gradient of this line, please. Use whatever method you want, but give me an estimate of the gradient of this line. Do whatever you wish, but do something.
Like,
how do you measure gradient if this is a EMATH question? Does your EMATH cover measuring gradient from a line, from a drawn line? No, really?
It does.
So how?
Find the amount of y decrease in the x.
That's I agree with you. So
rise of
can you do that? Yeah, correct. I agree. You just simply find the rise and the run. Totally agree with you. I think that's the method here. So find the rise and find the run. But graphically, visually, I mean, we're doing drawing here. Can you do that?
Yeah.
Okay.
So it would be something like goes from 1. Is it like 0.8?
How do you arrive there? I need to see the way you do it. You seem to be eyeballing something, and I don't know how. I mean, the number seems about right though, but how do you eyeball things? All right, I have okay, I have that. Yeah, nice. Then what else do you do? Why would you do that? Okay, sure. Yeah, I'm trying to follow here. Okay, then okay, nice. And then, so what are you saying? Is 0.8 over 1? Is it? That's what I'm saying, right?
Yeah.
You forgot the minus sign. It's minus 0 because it's a decreasing because it's dropping, right now.
Yeah.
Dropping when you view from left to right. When you view from right to left, is increasing. That's not what we do. We just view from left to right. Oh, decreasing, minus 0.1. A nice estimate. I like. Okay. Now, I'm going to turn on the cosine graph, right? Remember what I say to you? the differentiation, I claim the differentiation of sin x is cosine x. Don't know what that means, right? But I claim that the differentiation has a function. What is a function? The purpose. Just read the Jamboard again.
Okay.
I claim that the purpose is
predict the gradient.
Yeah, the gradient of the original curve. Okay, so the gradient of sine x. Cosine x, which is the differentiation, will predict the gradient of sine x wherever you wish it to be. In this case, I wish to predict the gradient at 2.5, right? That's your random point, correct? So this number is not a coincidence at all. Look at that. Look at that. This number comes from the blue curve, right?
Yeah.
The blue curve predicts a number minus 0.801, which is very close to what you think the gradient is. This is not a coincidence at all. Both you and the blue curve are thinking about the same thing. Okay, so far so good?
Yeah.
Going to test one more random point. So I'm going to clear all going. One more random point, please.
Like 1.
1. There you go. So I'll do the honor of drawing the line for you, yeah?
Okay.
Am I doing a good job?
Yeah.
All right.
Oh, no. No.
Okay. How should I do it? Could you direct me on how to do it?
I have to be like just barely. Or something like that.
Oh. Yeah. So you don't erase yours. Which one? The first one or second one? Because your second one is closer to mine.
I think yours is actually more correct than both of mine.
All right, so don't erase. Okay, so we can actually do a rough prediction. Look at the angle form here, right? This one is smaller, this one is bigger. It's already a bit of an imbalance. Do you agree? I think the line should tilt more clockwise, like more on my side. In fact, I think mine need to tilt even more, I think. So why don't we delete both our lines? Why don't we clear all drawing? And clear yours. Look at that. Mine is also a little bit imbalanced, I would say. I think I have to tilt a little bit more clockwise. Correct or not? Do you see that? It's a visual thing. So I'm going to do that. Yeah. Actually, no, I'm going to do a different cut. Right? Think that. This is over. This is too much, right? Wrong. Maybe something like that. What do you think? Is it better?
Yeah.
All right. So you just do the second line. Maybe I'm overshooting a bit, but that's what humans do. What to do? Estimate the gradient by your method.
Okay, so it would be like let's just say that the run is 1 and the rise is 0.4. 0.4.
So what do you think is the number here for the gradient, and also positive or negative?
Positive 0.4.
Okay, positive 0.4. I guess I can see why you say that, right? So roughly, human being roughly. So now let's turn on the cosine x. the value of 0.54. Not very far from 0.4, I would say. 0.54 though is guaranteed to be the better number because he's a very good predictor. Now, what I'm trying to say is not that you're wrong. I'm trying to say is you roughly guess, and it is very close to what the cosine x predicts. This is to illustrate my point. The cosine x job is first and foremost to predict the gradient of the original curve. And he will do so in very great accuracy. Right? So far, so good. So far, somehow can follow.
Yeah.
Now, if I change cosine x into something else, okay, you tell me, I'll just change it a little bit. What should I change it to?
Like change it, you mean by change it?
Like any way you want. We're going to alter cosine x into something else. Tell me how to
cosine 2x.
Okay, let's say cosine 2x, right? Okay, something we learned from 3, right? Okay.
Yeah.
And then now we look at the point here. This is the prediction, minus 0.416. Such a small alteration. The prediction is totally off already.
Yeah.
Minus 0.4 is not close in any way to 0.4. The minus is a big deal, correct? One gradient positive, one gradient. So we can safely say that our cosine 2x is not the differentiation of sine 2x because he's not doing his job. Really not doing it, right? So by that simple test, we roughly know that cosine x is the differentiation of sine x. Whenever you feel confused with the word differentiation, because that's not a normal people term, we don't say, hey, how differentiated you are today. We don't say that to normal people and our friends, right? We don't. So it's a very weird term to understand. Whenever you feel confused with a term, just remember what I say. Is cosine x the predictor of gradient of sine x? Very mouthful, but that's roughly what it means. Okay?
Okay.
And you can test that statement quite readily. Yeah? Now.
Yeah.
You will now... I will now do my own... I'm going to clear. So, I'm doing another claim, okay? I'm doing another claim, right? I claim that if the original graph is cosine x, right? If the original is cosine x, I claim that the differentiation is something slightly weird and no explanation is given. This is my claim, right? You don't have to believe my claim. I'm not asking you to believe my claim. I'm asking you to test my claim. Okay, well, test yourself independently. Now, where do you want to test it? At least I adjust for you first.
Where do I want to test it?
Oh, that's up to you. Just choose one random number.
3.
All right, 3 is fine. There you go. You're going to test on this number. To make it less confusing, I'm going to make the differentiation disappear first, just the original one, right? Oh my goodness, the gradient is almost going to be 0, right? This should be fun.
Oh, wow. So we're going to draw a tangent.
Wait.
Okay.
It's very obvious that the gradient is going to be almost 0, right? Correct?
Yes.
Right. So I'm going to just show you the differentiation graph first. Look at that. Is it almost 0?
Yeah.
All right. So it's already predicting very well. Now I'm asking you to shift the point a little bit so that you don't have to draw a zero gradient line. It's very difficult to find a 0 gradient line. Very difficult. So can you shift the random point a little bit?
Let's say 2.
2 is fine. There you go. Okay, less 0 lah than just now. Right. Please measure your gradient and then let's see whether the prediction works.
Wait, what am I doing? Nope.
And the drawing, not so bad, I must say, not so bad. Not bad. You can improve it. Not too bad.
Better.
Not so bad. Not so bad. I mean, that's quite good. That's quite good. Visually, that's quite good. You're making use of your visual strength. Now, measure.
I'm not even wearing my glasses right now.
Well, why are you challenging your life?
No, the lens popped out. And I'm
Oh.
too scared to put it back myself.
Okay. Can ask your dad.
Yeah. So that like if it breaks, then it's not my fault.
You'll be fine. Your glasses probably not. Okay. Although you may secretly wish for it to break. Maybe.
Not really. I mean, I don't mind new glasses, but I've had them for a while, so wouldn't mind a change.
I agree. Yeah.
So this is -6 or
so it's gonna be a negative, right? Negative.
-6 over
0.6. 0.6.
Oh yeah. -0.6 over. We get ourselves -0.231. What?
Measure it properly. You kind of bad, isn't it?
Rise over run.
Right. The rise is 0.6. Okay, can I accept that? Your run?
2.6.
You nonsense. Come on.
Oh
Nonsense.
wait,
Nonsense.
just 0.6.
Okay, good.
So it's -1.
All right. So your approximate you think it's negative. I think it's quite close. I think. Okay? So turning on the flame differentiation, right? Turning on. Pung. Where do you want me to check? Tell me. Where am I supposed to check?
Oh wait, I'm not on draw anymore. Just a sec.
Yeah, at this point, it really looks like -1, isn't it? Very, very close.
Yeah.
Very, very close. So my claim is roughly substantiated. I mean, we don't know for exact, right? Maybe our measurement is wrong. Maybe minus sign is a bit wrong, but it's roughly there. Fair enough? That means if I claim that cosine x, the differentiation is sine x, I am totally wrong. Make sense?
Yeah.
Right. So I'm going back to minus sine x, and I'm going to show you the general trend. So now use your visual ability. Yeah. Now look at the point here. Look at the point here. What's the gradient here? Look at that. That's easy.
1.
Hey, it's horizontal.
It's 0, 0. Sorry.
Zero, right? So what does the differentiation predicts? 0. Nice, right? Now,
Yeah.
how about another point? For example, this one. Look at that. What's the gradient of this one?
That is -1.
That's the y
0.
coordinate. Yeah, 0.
Oh.
So what does the differentiation predict?
0.
Nice, right? How about this point roughly? This point roughly right here. Roughly this point here. The gradient seems to be
1.
Around 1. Correct. Around there. 45 degrees. 45 degrees around 1, right? So the differentiation predicts 1 also.
1.
The differentiation is going to be able to predict anywhere you want, not just 1 point or just 2 point. That's the everywhere rule. So you can predict. You can ask him to give you the gradient everywhere you want. Just specify him where. Okay? He will always be correct.
Okay.
Right? So this is the main function, and it will take some time usually for the class to get to this point. They will just start with something that doesn't make a lot of sense, but at least easy to follow, but not the understanding. I give you the understanding first. So far, so good? Yeah. No. We are stopping the screen sharing. We're going back to the Jamboard. How many times do we have? We have some. So I'm going to ask you to memorize. Memorize. Easy to memorize, easy to use, right? There's an informal rule that I'm using here. If you go down, you're differentiating, right? So let's say S sine, at the bottom is cosine. So I'm basically saying to you, the differentiation of sine is cosine because it's down there. Here's an informal way of writing. So first, okay?
Yeah.
There's a reverse of differentiation called integration. What's integration? It's just the reverse of differentiation. If cosine is the differentiation of sine, then sine is the integration of cosine. That's a mouthful. That's just what it means, that reverse of differentiation. So far, so good?
Yeah.
So going down, going up. Look. What's the differentiation of sine, Aditya?
Cosine.
Yeah, very weird, right? Don't know where according to this memorization. But I did show you that at least this part with the graph seems to be correct, right? At least I show you lah. At least I give you some reason to believe me, right? So what's the differentiation of minus sign?
Negative cosine.
What's the differentiation of negative cosine?
Negative sine.
No, sine only.
Oh, yes.
And the cycle repeats. Do you notice that? It's now infinite, look. Minus sine, cosine, minus cosine, sine again, or then cosine, then minus sine. You get what I mean?
Yeah.
What's the integration of sine?
Negative cosine.
Yep. Which you can see down there. It's a infinitely repeating. Right? So the memorization, even though it doesn't make a lot of sense right now, I just show you some sort of proof, I guess, but it's kind of easy to memorize. So we start from there. So far, so good?
Yeah.
Okay. Going to the next page, I'm going to show you a few other differentiation, right? So this is a very simple polynomial. So you're going to make a polynomial for me. Make a polynomial for me, please.
Like any?
Any, but spell it out to me lah.
2x squared.
All right, sure. Then
plus 5x.
5x minus
4.
4. Okay, to spice this up, I'm going to put this as minus. Okay. Now, remember dy dx or y prime is just, the way of writing. I'm going to differentiate this guy. Now, for the integration side, there's also a symbol. I'm not explaining the symbol. I'm just showing you the symbol. Integration of y with respect to x. Y like that one, just follow for now. Or sometimes written as big Y. Sometimes written as, not to be confused with the linear law. So that's just how they formally present. So far, so good. We're going to do differentiation and integration directly. Right? And then we're going to prove it, see whether it's correct. Now, look at how I do it, okay? I'm sorry, I should be using. Okay, I'm trying to say the 2 is still there. The x is still there where I'm differentiating. Don't know what teacher Philip is doing, but that's what I'm doing. But suddenly the power from 2 becomes 1. Okay, which is different from the sine and cosine d. The division of trigonometry is different rule-wise from the differentiation of simple polynomial. 2 becomes 1. And then the 2 here times 2. That's the only two rules of differentiating this simple polynomial. So the result will be 4x. Why are you doing this, teacher Philip? Well, I'm not explaining it to you, but I'm going to prove it to you whether I'm right. Yeah. Minus 5x, right? So what happens to the minus 5? Still there, right? Still there. The x is also still there. So far, so good. However, the power from originally from 1, correct? It becomes what? Reduced by 1, it becomes 0.
0.
Because originally, just to be clear, it's 1 month originally. Right?
Yeah.
Okay. And then, remember, there's another rule. The 1 also times in front, so times 1. Doesn't change anything, but I just want to say that's okay. So this becomes, what does this become?
-5.
Yep, -5 with no x at all. Just say.
Okay.
Now, last one. What is the differentiation of -4? Do you have any idea? Just to be clear, this. Oh no, surprisingly not. Just to be clear, this -4 means -4x to the power of 0, if that makes sense to you. Just to be clear.
Yeah.
So I'll make it very short. Even though you will be tempted to say x to the power of -1, however, remember that the 0 goes here, right? 0 times everything, right? So, surprise, surprise, the differentiation of -4 is 0. Nothing, it's nothing.
Okay.
Right. It is very easy to understand. Very, very easy to understand. I'll try to explain the last one. Y equals to -4. I'm just explaining the last one, right? So y equals to 4. What kind of line is this? Can you draw y equals to -4 from which side? Do you have any idea?
Y equals to -4 would be like. Oh wait. Sorry.
What? Well, no. Y equals to -4 is not that, surprisingly. That's y equals to -4. Look at that.
Oh yeah.
That makes sense to you, yeah? Makes sense, yeah? It's not a line which is slanted. It's a horizontal line in this case. Because every point on this line is y equals to -4. That's what it means, right? No matter what the x line. That's why you see no x. Now look at the gradient of this line. What's the gradient of this line? Obviously.
0.
So therefore, the differentiation of -4 is 0. 0. This is a line, right? -5x. What's the gradient of -5x? -5. Well, would you look at that?
Yeah.
The rule, although doesn't make sense, is giving you results that make sense. Okay? I'm not claiming that the rule makes sense. I'm just claiming that the rule is kind of easy to follow. Same like the sine cosine thingy. It's a very weird rule, but easy to follow or whatever. But it gives you a result that makes sense. So far, so good?
Yeah.
Okay. Now, I'm going to try integration. So, what is integration? The only definition of integration that we need to know right now is integration is the reverse of differentiation.
Oh, okay.
Right. So I'm trying to find something on top here, which if I differentiate become this low symbol, right? Correct or not? That's what I'm trying to do. That makes sense?
Yeah.
Okay, so give it a try. So the x is still going to be there. The 2 is going to be there. The x is going to be there. Now let's start with the power first. The power will be 3. Correct?
Yeah.
Because 3 later on -2 and -1 becomes 2. See? How do I test my integration? By differentiating. Right? Always like that. Yeah. And now I'm going to do over 3 here. Do you know why?
No.
Because when I'm differentiating, you see what I'm You want to know why the integration is there? Just differentiate. When I differentiate this, 3 becomes 2. Well, that's correct. And then 2 over 3, remember the rule? Times 3, man. Remember?
Yeah.
2 over 3 times 3 becomes 2. Hey, see, my integration is correct because when I differentiate, I get this one. That's why I'm correct. Okay. There's something that I forgot. There's something that I forgot to do. I forgot to ask you to do. I should ask you to practice first lab, right? I should ask you to practice differentiation. So here's another polynomial. Okay. So something more challenging for you, right? Okay, go ahead. Please differentiate this thing. You don't have a camera, so you gotta write something like.
I don't think I got a question.
Can you see the question? It's on the same page.
Yeah.
Okay. Right. So try to follow the rule, even though you may not understand why. So try to follow the rule.
So, okay.
Okay, so the proper answer, sorry, I cannot write very quickly, right? So it's obvious for this topic you need to write. So, you know, on oh my goodness, we're gonna meet once a week, isn't it? I cannot even say on the next day. Well, when we meet next time, do have your phone ready so that you can write free. Okay. So the answer will be minus 6x squared. Is that what you mean? Okay. Then this will be plus x1 here. Then this will be plus 0. Just Aditya, is that what you mean?
Yeah.
All right, good. You're following the rule, even though you don't know why it works, but it works out. We'll demonstrate again. Right? Now, my challenge to you is for you to now integrate. Integration is just a reverse of differentiation. See whether you can do that. Please integrate.
Is that it?
This way, sorry. Where did you write down? Sorry, I don't get what you're writing here. I'm not getting what you're writing. So just informally, if you write integration, right on top, the thing you're just inform, right? So just gonna ask you, right? So x to the So if I'm trying to integrate this guy, okay, so it will be x to the power of what? The power first. You deal with the power first, the easiest way.
1. Oh,
Why would it
negative
be
2.
1? Why is negative 2? It's 4. It's 4. Because remember, integration is the reverse of differentiation. You try to differentiate x to the power 4, you get x to the power 3. Makes sense? So it's 4.
Okay.
Right.
Wait, how would you get 3?
4 minus 1 is 3.
Oh.
3 minus 1 is 2. That's the rule. It's a very weird rule, but that's the rule, I guess.
Okay.
Right. Then the guy in front. Okay. The guy in front will still be minus 2. The minus 2 stays there. But over 4. Why? Why? If you differentiate, the second rule is the guy in front is minus 2 over 4 times 4. What does it become?
Minus 2.
Minus 2. So this must be correct. Are you okay or not, Aditya, with the rule? I'm not saying that it makes sense, but the rule is like that.
It kind of.
Yeah. Should take some time to get used to. Now, try integrating, please. I am flipping your brain here and there, here and there, here and there, so that when your teacher talk, it should seem easier. Right? This is by intention, yeah. I'm flipping your brain to get you used to it. Please integrate, please. Right on top.
Okay.
I kind of agree with the 3, right? So let's start with what's correct. Okay, I think the 3 is the easiest rule to follow. So this is 3 and this is power 1. Totally agree with that, right? The minus I also like. Now let's talk about the 2, right? How do I test your integration? By doing what? By
flipping it or something?
by differentiating.
Oh, yeah.
That's how we test
Oh my
integration,
God.
by differentiating, right? Because we're just doing a reverse differentiation, right? So we just differentiate that rule. So obviously 3 becomes 2, you know, I like it. This 2 will remain, and remember the rule, 2 times 3. I will get 6 here. Therefore, is your integration correct?
No.
No, correct. At least you can at least you realize that it's wrong. By following this weird rule, you know that it's wrong. That's already an improvement. What you should be writing is positive. Remember, the half is there, right? The half is there, divided by 3. If that makes sense. Does that make sense?
Yep.
Because then half divided by 3 times 3 becomes half. There you go. Simple stuff. Simple stuff.
Yeah.
If that makes sense. Now, the 7 here, the minus, I totally agree, yeah, becomes 1 over 7. Is that what you're writing here? 1 over 7. Right? How do we know whether it's correct or not? Yeah, differentiate. So 1 over 7x. The x is gone. Totally agree with you, x above 0. Does the 1 over 7 stay? Yeah. Hey, wait a minute. I'm supposed to become 7. But this is 1 over 7. So I think the 1 over 7 is wrong. If that makes sense?
Yeah.
I'm kind of confident. So what should it be? Should be, instead, the 7 stay, right? Remember, the 7 always stay, and then divided by 1.
Oh, okay.
Oh, it remains
Yeah,
7, but that's not my point. My point is 7 divided by 1. I think it's easier to remember that way. 7 divided by 1, right? Or it remains. Why? Because, I mean, I think I'd rather see as 7 divided by 1. Easier for me. Okay, so you're getting the rule kind of ish, even though the rule doesn't seem to make sense. Okay, yeah, so far so good.
Yeah.
Now, please integrate this one just for practice. Okay, please integrate this one. Okay, and then we'll go see whether we're actually correct by looking at this.
Okay.
Please do so.
So this should be 2.
Yeah, we start from the power. Good, good. You always start with the power, and that's 5/2. Yep, done. If you differentiate, you will be correct. Good job, right?
This would be, there'd be an x here.
I think there'll be an x there, right? Power 1, 4/1. Done.
Oh yeah.
Right. I mean, just to be clear, right? But I think you're following the rule kind of already. Right? The rule for polynomial is different from the rule for trigo. Right? Both are easy if you get used to it. Okay, now that's not why you're interested. We're interested to see whether I am bluffing you, you know. I might be teaching you all this rule, you know, not explaining stuff, and turns out I'm wrong. Why bother? Right? Why waste time? Right? Okay, so we go to Desmos. Now you're gonna help me, okay? You're gonna read for me the result, because let's say I don't remember the result. Okay, you're just gonna read for me this guy and then the result, correct? Read for me. Okay, so first of all, let's erase sine and cosine, because you know that's correct already. Okay, read for me the original graph first. What is it? Share my screen.
Wait. Okay.
Share the screen. I'm sorry, where share the screen. Okay, so you tell me what's the original graph? Y equals to
sine x.
Sine. No. The polynomial one. The polynomial one.
Oh.
The one in the Jamboard, right? Because we're trying to test that. Am I bluffing you?
2x squared minus 5x minus 4.
Wait. Yeah, 2x squared, right? 2x squared. Sorry, minus what?
Yeah.
Minus 5x minus 4. Okay, so that's the original curve. And then I claim that by following the rule, we have a differentiation, which is
2x minus
5x. 4x differentiation of 2x squared is 4x. Am I correct? Differentiating to x squared becomes 4x. Yes. And then minus
4x minus 5x.
Minus 5 only, minus 5.
Oh,
and then plus 0, so like that. Okay, that's my claim lah. That's my claim. I'm gonna put that claim to a test, right? Okay. Now, are you seeing my Desmos? That's what we end up right now. So far. Okay.
Yeah.
Okay, I'm gonna close that, and then random point. You decide. Random point? No. Aditya?
Phillips, your voice is breaking.
Sorry. Random point, Aditya? Random point.
6. Negative
6. Negative. Okay. 6 might be too difficult to measure. You see that? 6 is a bit too difficult. Choose an easier point to measure. The quadratic is like sorry.
Negative 6.
Negative 6 here. Look, it's too up there. Also a bit difficult to measure. Something easier to measure.
Oh, right.
A bit too difficult.
Negative 1.
Negative 1 seems reasonable there. Negative 1, Okay. So go to negative 1, right? So that's the point, right? Okay. But what are we supposed to do? How do we test? Oh, even this is gradient, so it's very difficult. Right. Let's still give it a try. So I'm gonna give you annotation, right? Annotation. Oh, you can already have annotations. As per usual, estimate the gradient and let's see how well the differentiation performs.
So it would be rise over run, which would be negative 3.
Around there, but you're supposed to draw the line first, right? You didn't draw any line, though.
Oh.
Right, remember, supposed to draw the tangent line.
Totally, absolutely forgot.
Yeah.
So, it's gone.
Oh, I'm so sorry. I forgot. I'm supposed to work there. I'm supposed to move this. Yeah. Sorry, you're still there. Okay. Yeah. Wait, that doesn't look like a line that glances the curve. That looks like a line that cuts through the curve.
Yeah.
Glancing, right? Okay, visually, it's a good practice. Visually, glancing.
Is that more glancy?
No, that's super. No, here's glancing. Here's glancing. So let me try. Doesn't even this is not glancing, that's cutting, right? That's still cutting, but better lah. Better, so clear my drawing. There.
Oh, that direction.
Remember,
Oh, yes.
does that make sense? That is glancing. Visually, you have to see it. Even that doesn't seem to be the a very good one, but I mean, what to do? I just use mine. This one is a bit too steep already. That's why it's a bit difficult. But just use mine.
Okay. So it would go like from, let's see. -4.4 -1.2. So
It's gonna be negative, right? Okay, I agree. Right? So that's very steep, right? It's a very steep gradient. Right. So let's see. Your prediction is
3.67. Huh?
No. I think something very big. Are you sure? The rise is already 4,2, right? The rise is 4,2. Correct or not?
That's 4. Well, 4,2.
Hey, no, I'm sorry. The rise is not 4,2. The rise is 1,4. Sorry, 1,4 rise around there.
Yeah.
And then the run is 0.2, correct?
0.2, yes.
Right. So 1.4 over 0.2 lah, which is around there. What is it?
7.
7, but -7, correct?
Yeah.
-7, right? So to end today, let's check with I reveal the predictor. The predictor is there. I will have to shift the graph down, yeah, to mine, yeah. I have to shift the graph down.
Yeah.
What does it predict? It predicts that the gradient is -9. -9 is, frankly speaking, not very far from -7. -9 is the correct answer. At this point, -7, -9 is very difficult to draw one. We're choosing a very steep gradient. Right? Yeah. This doesn't convince you totally that, you know, the differentiation is correct, but at least it shows you that it's around there. Same with the sine and cosine. Okay?
Yeah.
I'll show you something else. What's the gradient here? Obviously.
Zero.
0. And the predictor say?
0.
0. I'll show you another more telling one. The gradient over here is all negative, correct? Correct. It's just negative. Look at the predictor, all negative. The gradient on the other side is positive, correct? The predictor, all positive.
Yeah.
The predictor kind of knows what he's doing. basically. So when we follow the rule, it does give us a very good. After we discuss all this basic thing, the application question will make full use of the predicting capability. That's what. That's what they want to do.
Okay.
Right. So that's our short introduction for differentiation. Hopefully, when I see you next Sunday, you will be able to ask more advanced questions.
Okay. Yeah.
If there is anything else.
No.
All right. Then for now, good job for today. I will see you next Sunday.
All right. Thank you.
Bye, Aditya. Okay.
Bye.
And then Kak Brian, yeah, I was just closing the breakout room.
Yeah, we saw, yeah.
Apologies, I didn't answer it very fast, but I answered the question 10 already. Did you guys discuss?
Yeah, we did.
All right, does it make sense?
Yeah, correct.
Okay, right. Is there anything else you want to discuss, or can we end now?
Like for those that we had time to discuss, we finished already, but then I think we didn't finish all the questions.
I understand. No problem. I think the discussion is more important. Right? Thank you, Kak Brian. Ainesh, okay? If it's okay, I'll see you tomorrow. Okay, we can talk more.
Okay, sure.